Hello, everyone. Good morning, good afternoon, or good night. I don't know, regardless where you're located. Welcome to the first Data Science Summer School organized by Hertie School Data Science Lab and Data Methodology Center at the Scripps Cluster of Excellence. I would like to thank our funders, the Scripps and the Stifterverband, for their generous support that allowed us to organize the school. And I'm extremely happy to see you all here on both Zoom and in the parallel stream session on YouTube. And I would like to note a couple organizational details that will help you throughout the workshop. If you're in the Zoom meeting, you're all muted and your cameras are off upon entrance. Please do not unmute yourself and do not turn your camera on unless you have a question. We really ask you to put questions in the chat because that way it's going to be easier to handle the questions for the TA and for the instructor. However, if you really want to speak up, you can raise your hand, and whenever there's going to be a good time throughout the workshop, we will let you unmute yourself, and if you want, turn your camera on and then speak up and ask a question out loud. If you're in a parallel YouTube stream session, you can leave your comments and questions in the live chat. We will handle them as soon as possible, either by answering the questions ourselves in the chat or directing the questions to the instructor and the TA through Zoom. And I want to remind all of you that the Zoom session is being recorded. And I'm thanking you all in advance for following these rules. And we continue today with the experiments topic and the experiments workshop. And today's topic is social media-based experiments. And it is my pleasure to introduce you Dr. Florian Voss. He is an assistant professor in political behavior at the Department of Government at the London School of Economics and Political Science. As a behavioral political scientist, he studies partisan election campaigns to identify the causal effects of formal and informal interactions between campaigns and citizens on electoral mobilization, voter registration, opinion change, and political activism. Florian, the floor is yours, and you can share your screen now. And thanks, everyone.
Yes, thanks a lot. Good morning, everybody. Thanks a lot, Olga and Hui, for organizing these great sessions, and thanks a lot to the Hertie School for inviting me and for having me. It's great to see you all today, and that you're interested in social media-based field experiments. Let me just briefly share my screen, and then we can get started. Just give me 1 second here. Right. Can you all see my screen?
Yes, perfect.
Perfect. Thank you. As Olga said, I'm Florian Voss. I'm an assistant professor in political behavior at the London School of Economics and Political Science. I'm a field experimentalist, meaning this is my kind of main method that I employ in my research. I've been conducting field experiments for about 9 years. And so how did the motivation of this workshop for this workshop come about? Well, when the pandemic hit about 2 years ago, quite a few of my friends and advisors, people around me kind of were a bit concerned, really, and they were kind of writing me emails and basically talking to me and asking, so Florian, what are you going to do? Because obviously many people thought it was no longer possible really to do field experiments, or at least the type of field experiments that we had come accustomed to, that we all had in mind, right? I mean, if you think about field experiments, many of us would think about, the kind of Gerber and Green style of canvassing-based experiments. While I obviously, I was very happy about the concern, I think these type of questions also at least partially misunderstand actually what the field means, right? And what field experiments really are about. And what I'm going to really try to show you today is that field experiments to a large extent are about the authenticity of several things, about the authenticity of the treatment, or the authenticity, for instance, of the outcome measurement. And so, once our lives moved online with the pandemic, so did politics, right? And actually so did field experimentalists. So what I did actually, or ended up doing in the last 2 years, were quite a few field experiments that were based on social media. I had conducted a social media-based field experiment before it's published in the PSIM. But, like these kind of trends, I think, moving kind of politics online moving politics on social media have been accentuated during the crisis. And I think so lots of field experimentalists actually have done field experimental research on social media and online over the past years. And that's really kind of like how this workshop came about. And what I'm trying to do today is to really share with you, I guess, some of the experiences that I've had over the past 2 years, some of the lessons that I've probably learned, what worked, what didn't really work in social media-based field experimentation, and I think and discuss with you how we can go forward from there, really. I'm lucky that I'm joined today by Katharina Laval, who is a PhD student at the London School of Economics and Political Science in the Government Department. You can find Katharina's website here, as well her social media, obviously, since this is basically a social media-based, field experiments class. Very lucky to work with Katharina, and I'm actually going to hand over to her now briefly to just introduce herself and say a couple of words about her research and her own experiences in conducting social media-based field experiments over the past 2 years. Katharina, over to you.
Great, thank you so much, Florian. Hi, everyone. It's really nice to meet you. My name is Katharina Laval. I'm a PhD candidate at the LSE. I mainly work on negative partisanship and what it does both to voters and parties. And another research area I work on, especially online, is inclusive politics. So how can we get underrepresented groups interested and mobilized in politics and get those individuals represented in political office? And as part of that research agenda, I conducted a social media field experiment last year on Facebook, where I was interested in understanding how effective social media campaigns on Facebook are in increasing immigrant turnout in local elections. And this was conducted in collaboration with NGOs in Germany. I'm also currently working on an ongoing project in the UK, also in collaboration with an NGO, which is about trying to understand what motivates individuals to donate to organizations who are trying to get more underrepresented women elected to office in the UK. So I'm really, really happy to be here. I'm very excited to talk about my own experiences with social media experiments, and also just to be of help and answer any questions you might have.
Yeah, thanks a lot, Katharina, and you'll meet Katharina in basically more in person, or in person, or virtually, in person later on when she'll be leading one of the lab sessions. Now, before we start, I just wanted to kind of walk you through very briefly the structure of the workshop today. So there are 3 parts, really. The first part is going to be about, definition of what we are talking about when we are talking about social media-based field experiments, or when I am talking about social media-based field experiments. I'm going to discuss some of the opportunities and challenges that we face as researchers conducting this type of experiments. And then we're going to really get into the weeds of it in the second session, where I'm going to discuss really social media-based designs or experimental designs that use individual level assignment, meaning where we assign social media users to treatment and to control group. And then the third, this will be followed by a short, basically our demonstration. And afterwards, we'll discuss social media-based field experiments that rely on cluster random assignment. Cluster random assignment being that users together in groups, in networks, in geographic clusters are assigned together to treatment or to control groups, and then we'll discuss what that means for analysis and for the design of our experiments. We really imagine this, Katharina and I, to be a very interactive type of workshop. So we want you to engage, ask us questions. Please do, code along. You will have been, shared a installation script file that has all the packages that you need in order to, to follow along the code that we will provide. We've also shared the code and the data sets with you. If you haven't received those, please let Hui in the chat know about this, and we'll share it with you. But, I think for now, if you like, in the background, do run the installation script files. So you're basically ready with all the packages, our packages installed when we get to the, more applied kind of coding part of this course. But for now, I really wanted to concentrate on, on the substance here. And, engage with a question, as I said, what are social media-based experiments? I want to talk a bit about platforms, social media-based platforms that we can use for experimentation. I want to talk about outcome measurement, and then also discuss, common concerns that we have with social media-based experiments, or also field experiments more generally, which are ethical concerns. So is it ethical to experiment on social media users? And then I want to discuss debates about generalizability, meaning, can we generalize from our sample? Social media samples are obviously highly selected to whatever kind of the target population in that specific research is. And there have been, and if you have been following along, debates in, experimentation and just, the social sciences and political science a bit more generally concerns that social media-based experiments are particularly prone to these type of generalizability challenges. Kevin Munger, for instance, has talked about, threats to temporal validity, meaning that, social media platforms keep on changing, and therefore, what is replicable today might not be replicable tomorrow. And that's not an issue, with how the researcher conducted the experiment. It's just the case that, the social media platform has changed. I'm also thanking my neighbors for, renovating the house at the moment, while I'm engaging here in teaching. But please excuse, the background noises. Nothing I can do about this. So first, I wanted to start with the definition of what field experiments actually are. When I talk about field experiments and social media-based field experiments, I understand them as a subset of field experiments. They are randomized trials. Yeah, but this is really key. So you have randomization, random assignment to two groups, at least, or multiple experimental conditions, treatment and control. And those randomized trials, RCTs, are conducted in the real world and real world settings. So the real world in general, as I said, my understanding of the real world is not necessarily kind of an in-person type of understanding of the real world, but it really consists of different dimensions that we should discuss. So the motivation underlying field experimental research is really to ensure a more realistic and unobtrusive intervention, for instance, compared to, experiments that are conducted in the lab or experiments that are conducted in survey environments. Those serve also lots of interesting purposes. For instance, they allow us to investigate mechanisms in more detail. They allow us more control as researchers, but that comes at the cost of realism, right? And this kind of realism we want to kind of introduce back into our research using field experimentation. So if I did, consider what the real world is, this might depend on different dimensions, really. And these are not binaries. You should really understand them as more of a continuum from, really authentic to kind of less, or more authentic to kind of less authentic. So the first dimension would be the authenticity really of the intervention or the treatment that we are conducting. Is, the treatment that we are presenting to subjects really similar to what they would experience in their everyday kind of normal lives? Is that something they would encounter in their real lives? Can they tell that, these interventions are kind of, they're made for research, or, do they think that these interventions, are really, administered in the real world? A second feature of basically authenticity is the participant pool. Are those actually kind of, the type of users you would encounter on, in this case, real world social media, like, your average Facebook user, your average Twitter user, or are they a selected, really kind of selected sample, for instance, that has been, trained to do experiments? Often you recruit people into online panels, and those online panels are used, for experimentation. So, these are people who have conducted hundreds of experiments before, so they're used to basically kind of being experimented on, or kind of fulfilling specific tasks for researchers. So that subject pool might be different, right? I mean, than the subject pool that you usually encounter on social media. Context is another kind of important factor. For instance, if you study the effect of specific social media-based interventions, for instance, online ads, on specific political outcomes, are you studying them in, contexts in which they would usually be used, for instance, electoral contexts? Often, social media ads are used in election campaigns. So if we want to test the effect of social media ads on political behavior, are we actually testing them in settings, in real world, electoral settings, where there's a lot of noise, right? I mean, elections are noisy, lots of other type of ads running. And field experiments would kind of aim at testing really this type of interventions in contexts in which they would usually be employed in politics. Fourth, the outcome measurement. Field experiments often really aim at behavioral outcomes. Yeah, they try to get not necessarily a for instance, intention to perform a specific behavior, which is measured via a survey, as you would often have it in survey experiments. But we would like to kind of measure specific actions that, in our case, social media users take or do not take. Signing an online petition, for instance, or turning out to vote. And then, as a field experimentalist, we would like to validate that kind of choice. So we would, for instance, try and obtain outcome data from public registers. We would try to match, for instance, in this case, social media data to real world data with all the kind of complications that this choice basically entails, some of which we will also discuss going forward. Yeah, but these are some of the dimensions that I really think about when I discuss, the authenticity of a treatment. So when I really kind of, refer to before, online experiments, being field experiments, it is, if a lot of your politics moves online, then, the online realm, the online environment is by definition authentic. So I'm not the first person, of course, to think about online field experiments or social media-based field experiments. Researchers have used different terms to refer to them. A definition I liked is by Muse and Penn, who really say that, they are type of experiments that leverage platforms or systems that already exist on the internet, platforms or systems such as Facebook or Twitter, to study the motivations and behaviors of individuals, organizations, and even governments. So, who the subjects of our research are, this can vary. It is often users of a specific online platform, but it could also be organizations, for instance. And these type of experiments tend to capitalize on the web's capabilities and the unique experience of cyberspace as an environment. So there is something specific about, also conducting this type of experiments on social media platforms. They provide specific opportunities, but also specific challenges. Andy Guess has a really interesting chapter in a new type of handbook, which is called Advances in Experimental Political Science, published by Cambridge University Press, where he talks about really three ways in which social media data can be used in experimentation. And there he really talks about the recruitment of subjects. Subjects can be recruited on social media. This is a strategy that has been widely used for both survey experiments, but also for field experiments. Then the delivery of treatments. So treatments, stimuli are delivered on social media, basically to subjects. And then third, there is collection of outcomes happening on social media. Some of those you could imagine being, for instance, retweet could be an outcome, or a share could be an outcome, a like could be an outcome. All these type of, like actions that you can take on social media. Now, as I said before, for instance, there has been a lot of really research that has both, recruited subjects via social media, for instance, via Facebook or Twitter ads. So I'm not really going to focus a lot on this in this workshop, because it's only 4 hours, and I could talk another kind of 4 hours about subject recruitment on social media. Outcomes can be collected on social media, as I said, like clicks, retweets, likes, e-petition signatures. I'll also talk a little bit less about this. it is one aspect of social media-based field experiments, which is also relatively obvious, I think. What I really kind of want to talk about is the delivery of treatments on social media. And this is also really what, for me, defines a social media-based field experiment. The treatment has to be delivered on social media. Yeah. For instance, you could collect outcomes also as part of a survey. For instance, there's a study we'll talk about in about an hour that was conducted by Andy Guess, Simon Monsert, and their colleagues, that, for instance, embeds a treatment that is delivered online in a multiple wave panel study. The same as I said, you could use register outcomes on turnout, for instance, and link those with social media data. Again, you could recruit your subjects online, or they could be social media users, or they could be recruited, for instance, via different means. But really the key is, and like all the experiments that I'm going to discuss here today, they will be about the delivery of treatments on social media. Yeah, so this is really kind of the definition, I think, that I'm going to run with, and where I'm going to spend most time on. And I want to really engage with you about design choices that we have if we try to deliver treatments online on social media. If I say online, I mean social media in this kind of respect. You could also obviously think about online type of treatments, for instance, email-based treatment that Katrina mentioned before. But really here, for the purpose of this session, it will mean on social media platforms. Yeah, so as I said, field experiments during the pandemic moved increasingly online, as did our everyday lives. So did politics. I can give you a couple of examples of that. Election campaigns are increasingly conducted online. There's more and more spending, which goes into social media ads, targeting, etc., on social media. This is not new. It has happened before the pandemic, of course, but these trends have been accentuated during the crisis. If you look, for instance, at the last US presidential election, or if you think about the coming German federal elections, I'm sure that spending online will be higher than in 2017. Committee meetings and even some parliamentary debates have been conducted virtually or in some type of blended format, where some politicians would be in the room and others would join from their computers. Politicians really meet their constituents now on Facebook or Zoom. They do like virtual office hours. Actually, I consider Zoom a type of social media for the purpose of this session, and we can discuss obviously whether Zoom is social media or not. Probably some people would say no, but it has some features that make it similar to social media platforms, then make it as well actually very well suited to online experimentation or social media based experimentation. And political talk, of course, has really kind of moved increasingly online and onto social media. Yeah, I mean, these are obviously chats that you follow amongst your even also real life network, your family network on Facebook. Could be strangers on Twitter, well-known people that you follow on Twitter. It could be some social media activity that is displayed on TikTok, right? I mean, which has become increasingly important for politics as well, and which is actually understudied when it comes to, for instance, social media-based field experiments. But these are some of the ways I think that politics really has moved online, increasingly online, into basically this online realm and the kind of the social media-based realm during the pandemic. So there's a huge range of existing social media-based field experiments. Researchers have studied the effects of social media ads and messages. For instance, messages for you to turn out. There's a famous paper by Bond et al. 2012. Really, that was one of the first studies that used Facebook, actually conducted in collaboration with Facebook, to look at the effects of of turnout encouragements on Facebook, the I voted button, which is quite famous. On turnout of Facebook users, I have conducted some voter registration field experiments. So, the question is kind of, can we register young people to vote using social media, since young people are, tend to be a lot on social media. We, for instance, have tried as researchers to induce political expression or deliberation on social media and see, like what it does to users. Does discussing politics on social media change political behavior? There's obviously a lot of work on the sharing of political information and the reduction of exposure to misinformation or disinformation. I mean, misinformation is obviously a big topic in social media-based research. So what can we do about it? Really, and experiments would look at kind of, what can we do to reduce exposure, for instance, to misinformation? Can we correct misinformation on social media? We could try and induce social interactions. We could even introduce people to each other on social media, see what that does to their behavior going forward and to the networks going forward. There's a lot of work on social contact and the reduction of prejudice and online harassment as well, which is obviously endemic on social media. There is famous work by people like Kevin Munger, Alexandra Siegel, who have really tried to target people who engage in, for instance, hate speech online, and basically enforce norms of better behavior online, and see what that does to their expression, or kind of what that does to the pronouncements of hate speech going forward. Do this type of social norm-based interventions actually work at making people's discourse more civil on social media? So these are great experiments to look at. We have tried to, obviously, lots of media, both what people refer to as legacy media, newspapers, but also new types of media are consumed online today. So, can we actually, what does media consumption online do to people? Does it make them more, for instance, if they keep on checking kind of Fox News online, or the kind of the Bild, if you're talking in Germany, kind of start page as their kind of default, if they have this as their kind of default browser setup, what does it do to their kind of political behaviors? People get a lot of news online, or obviously also on Facebook, on Twitter. So these are, another set of studies that really look at the effects of media exposure online. And then also the effects of social comparison. Obviously, social media is notorious for, making you compare yourself to others. Your latest holiday, for instance. During COVID, probably not so much. Or the latest item that you bought. And so what does it do to people if you follow, others who, for instance, display parts of their perfect lives online? Right? I mean, like, how does that make people behave, and how does it make people feel? A couple of experiments going in that direction. For instance, Instagram is quite an obvious platform for this type of experiments. For instance, my colleague at the LSD, Melissa Sands, has some experimentation coming forward, basically forthcoming on these type of questions, which are really interesting. Yeah, but there are lots of other experiments that I will have missed here, like where experimentation has been conducted on social media and online. So do you have any questions so far?
Nothing in the chat for now.
Okay, great. Then I'll continue. So now I want to talk a little bit, or at least briefly, about some of the opportunities I see in social media-based field experimentation and some of the challenges that I see. Key opportunity is most political actors and organizations are on social media today, and they use social media in order to persuade voters, persuade the public, mobilize, voters, in order to disseminate information, in order to learn about basically the public, in order to connect with other organizations. So we also have to think really about this kind of social element, right, in social media, and I'm going to talk more about what that means from the methods point of view, how this complicates really assignment and analysis in a bit. But it's really the case that, social media are widely used by political actors and political organizations. I mean, they are some of the major means of communication for some politicians. Yeah, some obvious ones who I won't mention.
We have a question in the chat. Sorry, Florian.
Yeah.
If TikTok is understudied, why are they less cooperative than Facebook? Annalise is asking.
Right. I think one of the reasons that TikTok is understudied, first of all, is because it hasn't been around as long as Facebook has, right? So there is this, I think, just a, probably a bit of a status quo bias there. It's also true that Facebook have been, well, they haven't been totally open, right? I mean, there is a lot of proprietary, basically, features on Facebook that you can't really access if you're not working with a company directly, but the company has been relatively open also, like more recently, to work with researchers or at least a selected group of researchers. There might also be, obviously reasons to do with the country in which TikTok and Facebook are based. So, Facebook being an American company or US-based company would have an easier kind of time, collaborating with US-based academics, which is where most of the research really kind of on social media kind of based experiments takes place, I think, at the moment. But I do think that TikTok is interesting and it's understudied. It's a little bit difficult to conduct experiments on TikTok for multiple reasons, which I'm going to speak about in a second when I talk a little bit more about platforms. For instance, it has to do with targeting of ads, which is harder on TikTok than on Facebook for the purpose of studying or evaluating the effects of those ads. But I think it's something which people will become increasingly interested in as they kind of go forward. I think one other reason might actually be, and it's maybe a bit of a reflection of our on my own field. I'm not on TikTok. Most researchers in their kind of mid-30s and beyond might not be. We are probably more comfortable with Facebook and Twitter, kind of maybe Instagram, but that's so I think it might be kind of onto a different generation of researchers, maybe, to do this type of work that are more kind of familiar also with those platforms than I am, for instance, in my own everyday life. And I think a lot of inspiration for field experimentation comes from your own interaction with specific, type of interventions as well. But I expect more to happen in this kind of space soon, hopefully. Social media type of interventions can be less costly in terms of time commitment. It's relatively straightforward to place an ad on Facebook or, Instagram. I'm not sure if you ever tried it. It's probably less time commitment than going door by door and knocking on like 1,000 doors. See what I mean? So, this can scale up relatively well as well. Like social media type of based interventions are probably easier to conduct at scale. Meaning if you also find something that works, this can be really valuable for organizations, can be really valuable for governments, can be really valuable for political campaigns, which is mostly kind of the setting where I personally do research in. So the scalability really of interventions is quite important. Yeah, so if we find something that works, can we actually apply it at scale in a kind of bigger setting? Yeah, so Felix is asking about my comment on kind of generational issues. Yeah, I mean, I agree with you that there is a lot of potential impact. I mean, we haven't really kind of looked at we have a lot of anecdotal kind of case studies of impact that TikTok had, but not that much systematic research on it. But yeah, I agree with you that there is a lot of potential there, definitely. Now, some challenges. As you will know, social media are very noisy. A lot of things are happening on social media. So effect sizes will be small, much smaller than you think they will be. And therefore, studies are difficult to power. When I mean power, I refer to statistical power. The probability that an effect will be significant if your assumptions about effect size are correct. So this is generally a major challenge in experimental work. A lot of studies are underpowered, but particularly so in social media, and that is because power is a function of effect size, or hypothesized effect size, and it just plays a major role. So if you have like a intervention that has some effect, but that effect is very small, you will need a very, very large sample to compensate for that, and that can be a challenge on social media in ways that I will get into later. Second challenge is that is treatment dosage, really, and the question of compliance, which can be very low. Compliance is really, like if I assign you to treatment, do you take the treatment? Yeah, or how much of the treatment do you treat, which is then, what I refer to as dosage, really. And I might, say my treatment would be, an invitation to come along to a, to engage in discussion on social media. And I would send this invitation to like 100 people. What if only kind of 2 people actually take up that invitation to engage in social media based talk? And this type of issues have been very, very common, and very common challenges. Also, Katerina can also tell you a little bit about her own experiences there. But it's more challenging than you would think it is. Yeah. So even if you also take the example of Facebook ads, right? I mean, like, so I can assign people to receive ads, but how many of those they will actually see and so on is to some extent down to the algorithm, right? I mean, on social media and outside of the control of the research. So I'm not necessarily, I can assign, for instance, people in a certain area on Facebook to receive ads, but the dosage of those ads is, might be too low. So there might be lots of other things going on, and people might not really kind of really engage or be able to engage with that kind of background or realize it. For it to be noticeable, I think is a real challenge. Yeah. Thirdly, attrition. Attrition is if outcome data goes missing. Yeah, it's different from compliance. Compliance relates to the treatment, whether you take the treatment if assigned to treatment, and whether you don't take the treatment if assigned to control. Attrition really is about the outcome variable. Attrition is about kind of, do I observe you in my outcome sample? And as you know, subjects close their account sometimes. They get banned from social media for engaging in some of the type of behavior that maybe we want to study or we want to prevent. And the issue with attrition is that if it's differential, it can induce post-treatment bias. And for instance, conditioning on an outcome that suffers from differential attrition is a big mistake in social media-based studies. Yeah, and social media is prone to attrition. So that's a major challenge too. Now I'm going to speak a little bit about proprietary platforms and data protection guidelines. And those really make it difficult for independent researchers to experiment with individual users. And
Florian, there's a question in the chat.
Great. So Ludwig has a question. Yeah. So what about incentives? The use of incentives in experiments to encourage compliance. Yes. So you can obviously incentivize compliance, can pay people, but you're doing 2 things if you do that. First of all, you might violate the excludability assumption. Excludability means that there is no other path from treatment assignment to the outcome than the treatment. And if assignment sets in motion payment, then we need to assume that payment doesn't change behavior in the end. And second, it might kind of make the treatment less authentic. Right? So we are kind of moving away here from this type of realism type of based experiment in the real world or the virtual world to more of a kind of a lab-based intervention, which is fine, but we need to know that this is not costless, right? I mean, yeah, you can work with incentives. They're obviously costly by definition, but also like they have a cost in terms of authenticity, yeah, and in terms of potential excludability violations. Other than that, it's fine to work with incentives, and we have done so. Yeah, so in terms of how power works, I'm actually going to show you a very basic power simulation kind of platform later, a Shiny app that you can use for power. But just like very kind of at the basic level, power is really like the proportion of experiments that will come out significant if your assumptions about effect size and standard deviation or variance are correct. Yeah, for instance, so if you're right that the real effect of an intervention is 3 percentage points, and you conduct an experiment, what is the probability that this experiment will be significant at the your given chosen level of statistical significance at the 0.05 level, for instance? And the usual threshold that we're using is 80%. 80% of your experiments will allow you to reject the null hypothesis that there's no effect of the intervention if you're right and the true effect of the experiment actually is 3 percentage points. So given that you're right about the effect size in the real world, what is the probability that you'll find a statistically significant result? That is what power captures. Yeah, and what we want to do is we want to kind of maximize that probability. Yeah, we want to be able to at least 80% of the time be able to reject the null if we're right. Better 90% of the time. Yeah, and that means most of the time, I mean, you can do two things as researchers. First of all, you can try and increase effect size, which is something that I recommend in any type of social media-based studies. And, you can use a hammer, meaning try and get an effect in the first place before you go into kind of, for instance, investigating any type of mechanism. That is one of the approaches that I have chosen. You could go the other way around, but I still think it's the most promising kind of way forward. So work on effect size, maximize effect size from a theoretical kind of point of view. So, choose interventions that are, meaningful and recognizable. Second, increase sample size, if you can. But one major difficulty is clustering, meaning that often you cannot, because of the proprietary kind of nature of some platforms like Facebook, you cannot assign individuals to treatment and control unless you either work with Facebook or you have actually their specific, contact details like the email address ready. And then, there's some instances where you can target individuals. But if you target at some kind of cluster level, which means basically at the geographic level, the city, the postcode sector, and so on, or by interest, which you can on Facebook or other social media, you will run into power problems and power challenges, and that's exactly what happened to us and to other researchers who have tried and do, this type of experimentation on social media. I'm happy to send more readings going forward. If you email me, I'll drop you an email with readings on power. So that's really difficult, and as I will show in a second, it's really about like some media platforms are more welcoming to researchers than others. Twitter is very welcoming. It's the most open probably of all kind of social media platforms, while other social media platforms are more close to researchers, and that means that is also one reason why some researchers, there's so much research on Twitter, right? I mean, because it's easy to assign individual subjects on Twitter. It's easy to collect outcome data on Twitter and so on. Yeah, so often the choice of platform is driven by the openness of the platform to researchers.
Florian, there's another question in the chat. Any examples where useful interventions occur naturally on social media without the researchers inducing them manually?
Yeah, so this would be more like what you would consider a quasi-experiment or a natural experiment. So this can happen, right? I mean, but it's a little bit outside of the scope of this workshop today. Yeah, so example might be any type of policy change, right? I mean, that would be employed on one social media platform, but not on another social media platform. Different type of design, right? I mean, if you think about it, there could be a couple of RDDs that you can think about, but it's not really the subject of this workshop. But there are definitely some of those. Yeah, it's also difficult to match subjects' online and offline identities, which we often want to do because people don't use their real names on social media often, right? For good reasons. There are also financial costs that can be prohibitive. Yeah, so for instance, if you need to kind of target lots of people because of power, right? I mean, like this can be costly, depending on the type of intervention that you choose to employ. So therefore, I've kind of come up with a little bit of a ranking of social media platforms. You're free to quibble with this. It's not, it's mostly based on kind of anecdotal, basically experience and things I've read, not based on experimentation. So I think Twitter is the most open to experimentation, right? Twitter APIs, can register as a researcher. I'm not sure if you have done so, but for instance, the entire archive, right? I mean, like of tweets is available to you as a researcher with a university account. I think really up from master's level. Most Twitter accounts are not private. That really makes it welcoming to researchers. Twitter has, really also done a lot of work to be welcoming to researchers lately. I think they have understood that, this might actually be a type of asset for the platform going forward. Zoom is actually quite suitable for experimentation. I'm going to give you an example later on of a kind of Zoom-based experiment. I know Katerina is also working on one at the moment. Basically, you can easily assign people to different Zoom sessions. You can assign them to different breakout rooms, randomly assign them to different breakout rooms, and see what that does with people. Let them engage in talk. What we're doing today, maybe it's part of a randomized experiment, probably not. It isn't, right? But it could be. Yeah. Now, Snapchat is another platform which is quite welcoming in the sense of, like, for instance, that they allow the placement of ads at very low geographical levels. For instance, in the UK, where I work mostly, would be the postcode sector, which is the zip code, right? I mean, in the United States, which is, for instance, something that TikTok and Google don't allow you to do. They let you mostly kind of target bigger kind of geographic areas, which makes it really, really costly to experiment, like, for instance, with digital ads on those platforms. I think Facebook and Instagram are a bit less welcoming than Twitter for the type of proprietary type of reasons, also, that I've already outlined. But there has been lots of, experimentation going on both on Instagram and on Facebook. So it's a good question about Weibo and Sina. I don't. Yes, so there has been experimentation actually using those platforms, and I would point you to the work of Jennifer Pan, who's at Stanford, and she has done some great work basically in the Chinese context on social media. Also, people associated with Gary King at Harvard have done quite a lot of work on that. So I'd really encourage you to look into Jennifer's work on that. Yeah, it's absolutely true. YouTube should be there. Yeah, it's an omission on my part. Yeah, YouTube is obviously a really important social media platform, and one I haven't experimented with on myself, but which I think is, could be really, I mean, it's potentially really influential, I guess, at also shaping people's opinions. Also, when it comes to, for instance, misinformation, right? I mean, there's been a lot of debate on misinformation on YouTube. Yeah, let me just move a little bit on so we can get into the kind of the more practical part of the session soon. I wanted to point to some basically potential complications, which are to do with outcome measurement. So, if possible, like we want to measure outcomes, like on the platform. If we do social media-based experiments, we want to measure clicks, we want to measure likes, shares, and so on. These are what we refer to often as intermediate outcomes. So these are outcomes that directly kind of, you basically conduct or administer treatment on the platform, and then you can directly measure the outcome on the platform. But often as political scientists, we want to go beyond these type of likes and shares. Right? We want to know, does it actually change political behavior? I can easily see, does my social media ad attract a lot of engagement online? Is it shared? Do people like it? Do they engage with it? Do they view it? Do they click on a link included in the kind of ad? That is something that I should be looking at and that I can look at. But it doesn't tell me in the end really whether, in terms of hard outcomes, in terms of like, did people register to vote, were they persuaded, in their political attitudes in this ad. These are outcomes we really are interested in as political scientists, because what do all these kind of likes and shares actually lead to if they don't lead to any change in political behavior, right? But so we are really interested in studying this type of hard outcomes, via public registers or via online panel surveys. And therefore we need to link often offline to online data. And that is a challenge, right? I mean, for data protection type of reasons, for, reasons to do with matching, right? I mean, names, for instance, online and offline, and all this type of related data linkage, type of data science, type of issues that you will also encounter in other type of research that is non-experimental on social media. So I promised you that I'll talk a little bit about generalizability, which is generally an issue that's often raised in field experimentation, sometimes fairly, sometimes a little bit unfairly, I think. But it is an issue that has become more and more important, and for good reasons. So on social media, obviously, we know that, and you have heard this, probably statement a lot: users of social media platforms are not representative of all registered voters. John Mellon and Chris Prosser actually also have a paper showing exactly that. But that doesn't mean that we can't learn anything from them, right? Because sometimes social media users are actually the target population. We want to learn something about social media users. Also, some platforms are more representative than others. Facebook is more representative of the kind of general voting age population than Twitter. It depends by country, right? I mean, like in some countries, certain social media platforms are more representative of the population than others. Think about Telegram in Eastern Europe, where I'm based at the moment for a while. Or, for instance, Weibo in China, so there are really, context really matters here. So, and we can't really say, this is the most kind of representative platform or not. The key question is, so one of the key questions is, what is the target population? And I might add a second key question, which is like, do we have reasons to expect treatment effect heterogeneity? Right? I mean, do we have reasons to expect that our sample would respond differently to treatment than users that are not included in the experimental sample? And in the end, that is an empirical question, right? I mean, pertaining to generalizability. As some people that say that there is actually surprisingly little heterogeneity in how subjects respond to stimuli. I think my friend Alex Copper would be one of those people. Yeah, there is an ongoing kind of lively debate about this type of questions in the field, really. More, I think, importantly, there is a debate about replicability of social media-based field experiments. Really, that has been started by Kevin Munger, and I really think that he's getting at something here, which is because social media platforms change so quickly, that has implications for the replicability of social media-based field experiments beyond, other type of, field experiments that you might think about. And he talks about temporal validity here. Usually you don't know which version of a social media platform you're engaging with. If it's like kind of Facebook 6.04 or Facebook kind of 6.5, etc. There are no version numbers. And it's difficult to keep track of all the features that change, and impossible to keep track of all the changes to proprietary algorithms that are being done on those social media platforms. So you're experimenting in an environment that you don't control. It's totally outside of your control. If you're not the social media company actually implementing those experiments, and therefore, there might be some instances where, for instance, some experiments worked meaning kind of they were actually implementable. A good example is the experiment using bots that Kevin conducted. Some researchers tried to replicate it, and the bots got banned from Twitter because Twitter changed their rules, right? I mean, like their usage rules, a year or 2 years after that experiment happened. So there's some things that lie outside of the control of the researcher. Something on the social media platform changes, you don't know, because the version it's control is totally outside, like with another actor, and therefore sometimes things might not replicate. And that means that social media based interventions might have a shorter shelf life than other type of interventions. Right? I mean, social media is more shortly kind of more kind of quickly paced, and therefore what's like I know that door knocking works, right? I mean, based on hundreds of field experiments, will probably also work in 2 years or 5 years, with some uncertainty about like how social contact might work after the pandemic maybe. But some social media type of interventions will rely on social media platforms, like not changing all that much over that time. That also has implications for publishing, right? I mean, like for instance, Kevin thinks we need to publish more quickly in political science and all kind of sciences, and I think he has a good point here. Yeah, to be relevant to that kind of debate that's ongoing. Finally, and that will be my last point in the introduction session. Really, I wanted to talk a little bit about ethics, experimental ethics, and there I wanted to point you to the APSA principles and guidance for human subject research, which have been passed by the APSA Council last year. And they are really a collection really of sets of ethical standards to which political scientists should be held. I've written down some of those principles here that are included in the APSA principles, which is individual researcher responsibility, meaning as a researcher, ultimately you take responsibility for the intervention, even if an IRB, internal review board, or an ethics board clears you or clears the experiment. Deviations from those principles require justification, meaning you need to justify if you, for instance, not using informed consent, as we often do not on social media-based kind of field experiments. You should, as a principle, respect the autonomy of subjects, and autonomy means that subjects usually should consent to participating in a study. Again, something that is often not done in social media-based field experiments or field experimental research more generally. You should be aware of power principles or power imbalances, both upward and downward, meaning, for instance, you should be aware if you're engaging with subjects who have lower education levels, who might be poorer. That might have implications for their autonomy to consent. You might be engaging with politicians on social media who might be more powerful, meaning that might mean that some other kind of ethical principles might be less stringently applied to more powerful actors. So consent is a big question. Really, I mean, already coming from kind of medical experimentation, but also now in kind of experimentation more fully in the social sciences. Deception is another one. Right? I mean, can I deceive subjects to, for instance, the goal of my study? Or do I need to kind of tell them what the study is about? Their disciplines have different opinions. For instance, economists are generally more opposed to deception than, for instance, psychologists or political scientists. We should avoid harm and trauma. Right? I mean, physical harm, of course, but also psychological harm to subjects. Confidentiality, especially important on social media, right? I mean, you should keep the sort of the identities of subjects confidential. Impact, which is about kind of what is the real world impact of the manipulation that you are conducting as part of your intervention. And then obviously we shouldn't break the law. Yeah, this is kind of a bit obvious, but might also be more difficult in some social media-based settings, where, for instance, some platforms have regulations that you shouldn't take on a false identity, right? Which also relates kind of back to the deception point that I made earlier. Now I got a couple of questions that I would like to respond to. Yeah, so we had the question whether those principles and guidance, like what I just discussed, wouldn't apply kind of more broadly. Of course, they apply more broadly. They apply to all type of, research that engages with human subjects. But I think some of those principles or really points here are more relevant, or kind of are more likely violated, or like not respected in social media type of field experimentation, particularly, or there are challenges to it, particularly deception, consent, confidentiality, and impact. Impact because of the scale of experimentation that is often necessary in order to power your studies well. And that means that you're going to change outcomes broadly for many people, right? And what does it actually mean for the political and social world? These are some of those questions. Now, it's really important to emphasize that these are not kind of principles that forbid you to do any type of this type of research if you don't respect them. But it just means that you need to justify deviation from those principles. You should engage with those in your paper. For instance, your paper, and now it's have been adopted by the APSR, for instance, our flagship journal in the discipline. They want you to engage with, like if your experiment does not ask subjects explicitly to consent to being part of the study. Because it might be impossible, say for instance, you're studying discrimination online, telling people that you study basically that discriminatory behavior might lead them to behave in different ways, a phenomenon called the Hawthorne effect. You might have good reasons for deviating from those principles, but you should be able to justify them, which is something you anyway need to do, I think, in most ethics applications. Yeah, so here's the principle on impact, actually, that I wanted you to read, which says that, political science researchers conducting studies on political processes should consider the broader social impacts of the research process, as well as the impact on the experience of individuals directly engaged in the research. In general, political science researchers should not compromise the integrity of political processes for research purposes without the consent of individuals that are directly engaged by the research process. It's important to specify that this applies for researchers working as researchers and not working in collaboration with political organizations that might have a different legitimacy of engaging in that type of manipulation, basically understood as a technical term, not a normative term, that might lead to different political outcomes. As say, for instance, if you're working with a political party, in Germany, for instance, political parties have a constitutional role in forming public opinion. Therefore, they have a certain type of legitimacy. So that wouldn't apply here. Yes, this really applies to you as a researcher conducting your research on platform. And therefore, you should be aware of the, you should think through some of the, impacts that your research might have on political processes. This is a controversial principle, especially for field experimentalists, because often we say the whole point of field experimentation is to have impact, right? Or to come up with interventions that work in the real world. So by definition, they will have impact. So is that a kind of a hindrance to field experimental research? But I think I've come around, like engaging quite in detail, I think, with those ethical principles over time, and also in the debate about those principles, that some of this is actually kind of good for the discipline, to the extent where I think we should be aware of those, like challenges that we face as field experimentalists, and we should address them explicitly. And if we have different opinions and we can justify deviation, we should. But we should do we should be basically forced to do that explicitly. I think in our papers, I think it's not a bad thing per se. As long as it doesn't, I think, prohibit most work, like on social media type of experimentation. Because, if we don't do it as basically researchers, it will be done by platforms. It would be done by campaigns. It would be done in-house without scrutiny and without transparency. And I think that is really what we add as researchers to that kind of process. Right? I mean, because we are researchers and we are transparent about what we do, or we are becoming more transparent about what we're doing, we also are subject to more scrutiny. You're subject to experimentation on social media platforms all the time for good reasons, right? I mean, because that is the way that impact evaluation is done, how, social media platforms test different new kind of features or tools. But saying we don't do that just means that, you'll be experimented on in private instead of in public. Yeah, so I'll give you examples now, actually, which are like 2 case studies that I want you to engage with in a second. Yeah, in breakout rooms for about 10 minutes before we break. I just wanted to say, so why do field experimentalists often forego informed consent? And that is really to avoid the Hawthorne effect, really, which is to avoid bias in the estimator. It's about the realism of the intervention and construct validity. There are also some behaviors, such as discriminatory behaviors that are very, that are almost impossible to study if you tell people that you're studying them, right? Another reason really is assignment. Often I can't assign individuals to treatment or control, so I don't know who the individuals are that are being targeted by my intervention. I just assign geography or geographic kind of areas instead. So in the end, I think, one way of thinking about it is a type of cost-benefit calculation, right? So, I mean, are the potential costs of foregoing informed consent or of deceiving subjects, for instance, outweighed by the potential benefits that I could gain in kind of knowledge accumulation, in, coming up with an unbiased estimator, using field experimental methods. There might also be costs really to informed consent or not deceiving subjects, which is bias. Yeah, so there's this kind of trade-off often that field experimenters see between bias. I get kind of some biased estimate, which is something, even if I generalize it, what can I learn from something that's biased? On the one hand, and then, not respecting some of those principles of, like ethical principles on the other hand. And I think that is basically a calculation that researchers have to make together with other researchers. And for instance, also together with ethical review boards, or kind of with peers, with reviewers, journal editors, and so on. So I wanted to give you now 2 cases, so hypothetical case studies that are both not very hypothetical because they're based on real cases. And I would like you to, go into breakout rooms, breakout rooms of about, I would say, like 8 people each, and discuss those cases for about 10 minutes. And we'll come and join you in those breakout rooms. So the first case is about researchers that partner with a social media platform to test if displaying a larger or smaller share of positive or negative messages on their timeline affects users' expressions of their emotions. There was a study that has been conducted by researchers working with Facebook. Yeah, so what happened is basically that on some users, timelines or Facebook walls, they would see more happy posts or more kind of sad posts. And then, researchers would measure afterwards using automated text analysis or sentiment analysis. If their own post became more sad or kind of, or happy over time, it's what they refer to as emotional contention. And what I would like you to address here is, what ethics principles of the principles that I just outlined does this pertain to? Which of those principles does it speak to first? And then, do you think this study is ethical? If you don't think it is ethical, what could be done to actually, about the design of that study to make it more ethical going forward? Hypothetical case 2, its researchers assign young people in some postcode sectors to receive voter registration social media ads and young people in other postcode sectors to control. So they do not receive any social media voter registration ads. Then they count, voter registrations in treatment and control sectors from the public register, which is available in the United States or the United Kingdom, for instance, for researchers to access. And so that's the second experiment. And so if you could assign people into about like kind of groups of, I would say about like kind of 5 people, that would be great. And then Katerina and I will rotate through those rooms. We'll return in about 10 minutes.
Yes, should we start now?
Yeah, would be great. Thank you.
Everyone, so we will assign you to your own breakout room now. So please discuss the 2 hypothetical cases that Florian just talked about. And you can also get to know each other in the breakout rooms as well. Thank you.
Thanks. I will join you. Olga,
Yes.
could you invite everyone back in about 2 minutes?
Yep. Should we put them back in the breakout rooms, you mean?
The breakout rooms will
Just
end.
kind of, you know, back into the big room in about 2 minutes.
Okay, I think
Just, if you could just, could I join another room for just 2 minutes?
Oh, okay.
And then, you know, basically just dissolve the rooms after 2 minutes.
Okay.
Right, I'm sorry for cutting you off or for cutting your discussions off. I hope it was instructive, at least in parts. You know, in terms of like I think these are like real life, really kind of challenges that, you know, field experimentalists face if they engage in the type of work that we do. And yeah, I'm just encouraging you to kind of keep on thinking about this type of, you know, ethical questions in research, also like, you know, as they pertain to your own research. Again, like the idea is not that, you know, we don't do this type of work, but we do it in a way that maybe better corresponds, you know, like, or better respects these ethical principles. But, you know, in order to be able to do that, we need to know about them in the first place. I think so, you know, it's good to educate ourselves, I think. Great. So what I would propose is we take a 5 minutes break. We come back at 12:30. And then we're going to talk about, you know, social media experiments that are assigned at the individual level, and we're going to do a little R exercise together. All right. Great. Hello, everybody. I hope you got yourself a coffee or whatever the beverage of your choice is. We'll continue in about 30 seconds. Yeah, so make yourself comfortable. What I want to do now is I would like to, get a bit more into the methodology really of field experiments on social media, and particularly field experiments, where you can assign users of social media services individually at the individual level to treatment or to control. Or, in this case, individual assignment might also work. You might individually assign places individually to treatment or to control. Yeah. So it could be kind of units. Doesn't necessarily have to be users, but in most cases it would be kind of individual Facebook or kind of Twitter users, for instance. Before I do that, I wanted to introduce a little bit of notation. So this would be recap for you. I think if you have followed some of the other courses, for instance, also yesterday's course on experiments, but usually, we obviously index experimental subjects or units using subscript I, which refers to subjects 1 through n, and is the kind of the overall number of subjects in a sample. We usually define the treatment as the variable di, as a d basically indicates is the treatment indicator. It can take on 2 values, can take on the value 1 if the subject is assigned to treatment, and it can take on the value 0 if the subject is assigned to control. Yeah? If the subject does not take the treatment. If you have more than 2 experimental conditions, it could be kind of di equals 1, 2, and 3, where 1 kind of corresponds to the control. But for for simplicity purposes, we'll refer to it as basically di can take on the values 1 or 0 for now. So if I refer to the letter D, it's the subject's treatment status. We also assume that di is observed for every subject in the sample. Now you would have encountered potential outcomes before, for instance, thinking if you have taken, for instance, Julian Schissler's course, but I'm not sure if everybody has. So just a kind of quick recap. yi1 is our treated potential outcome. This is the potential outcome if the I subject was treated. And yi0 is our untreated potential outcome. It's the potential outcome if our I subject was not treated or was assigned to control. Yeah, so potential outcomes are counterfactuals. They're counterfactual outcomes. As you know, we can only ever observe one potential outcome at a time, which is the fundamental problem of causal inference as defined by Holland. But we assume, or we think that really, subjects, they have 2 potential outcomes. They have a potential outcome when they are treated, and they have a potential outcome when they are assigned to the control group when they are untreated. And, given, depending on whether a subject is assigned to treatment or to control, they will show you either the treated or the untreated potential outcome. They will reveal either the treated potential outcome or the untreated potential outcome. Now we can go further with that. So for instance, talk about conditional potential outcomes. And in this case, we're talking about the potential outcomes for a subgroup of subjects. For instance, yi0 for the subgroup of subjects that is assigned to treatment would be the untreated potential outcome for subjects that receive the treatment. This is unobserved, of course. So we will never be able to observe this outcome because it's the untreated potential outcome for a subject assigned to treatment. But it nevertheless exists. Yeah, we need to assume that every subject, as I said, has a treated and an untreated potential outcome. Then in this case, this would be yi1 for a subject that would be hypothetically assigned to control. In this case, capital DI. This is basically a term that I write when I refer to a hypothetical random assignment. When I, for instance, talk about the statistical properties of a treatment, or basically of a function. In this case, it would be the treated potential outcome for subjects that would not receive the treatment under a hypothetical random assignment. Again, this basically conditional potential outcome would be unobserved. Yeah. What would be observed is the untreated potential outcome for subjects assigned to control, and the treated potential outcome for subjects assigned to treatment as a yi0 for subjects where di is 0 and yi1 for subjects where di is 1. Yeah, this just as a recap on potential outcomes, because I will use potential outcome notations basically going forward. So the way I define an experiment for the purpose of this module, so also for the purpose of any other module really, is a study in which subjects are assigned to treatment and control with a known probability between 0 and 1. And the emphasis here is on known probability. Yeah, the researcher knows each subject's probability with which they are assigned. It has to be between 0 and 1, because if everybody has a probability of 1, everybody will be treated. There will be no control. If everybody has a probability of 0, everybody will be in control. Now, importantly, the probability of assignment needs to be equal for each subject. Yeah, which means that nobody has a higher chance of being treated. And it means that there is basically no self-selection into treatment. That is basically, that is what this, this statement really entails, which really, like goes to the core of what random assignment does. It ensures that everybody has the same probability of being treated, independent of a subject's background attributes, independent of a subject's potential outcomes. Yeah, so there's no attribute that could systematically predict treatment assignment. So for instance, if you are a social media user assigned to treatment, then you shouldn't have a higher probability of being in treatment depending on, whether you're a frequent poster, how many followers you have, how many times you engage in specific, behaviors online, how popular you are on the social media platform, this kind of things. This should, in expectation, be identical across treatment and control groups. That is what random assignment ensures. The different types of random assignment. Right? I mean, there is simple random assignment. In this case, each subject is allocated to the treatment group with a probability m over n, where m stands for the number of subjects in the treatment group and n for the number of subjects in your sample. Yeah, this would be, give you an example, coin flip. Yeah, so I would flip a coin about whether you are in treatment and control. This can lead to imbalanced numbers in smaller samples, especially in the treatment and the control group. Yeah, because in expectation, it should be equal, but in every given random assignment, you could end up, for instance, if you have a sample of 100 subjects with 60 people in treatment and 40 in control. This is accounted for in complete random assignment, a block random assignment, where in complete random assignment, you assign exactly m units to treatment and m units to control. Yeah, so same for block random assignment, but there you assign exactly m units within a subgroup which is defined based on a pre-treatment covariate to treatment and control. This could be any type of covariate that's measured pre-treatment, and it is specifically, why do we do blocking? Because we think that this pre-treatment covariate is predictive of the outcome, and it helps us to reduce sampling variability. It relates to statistical power, how we can increase our statistical power. So these are some common forms of, doing random assignment at the individual level. Yeah, so how can we do random assignment? We can, for instance, do it in Excel using the rand function. It's nothing I would necessarily recommend because Excel is difficult to replicate. Yeah, but it does work. Much better is to use the randomizer package in R, which has been written by some colleagues of mine, and which works extremely well. It's very accessible. One line of code allows you to conduct complete random assignment, simple random assignment, block random assignment, whatever type of random assignment you want to conduct, really. And we will introduce you to the randomizer package in the lab session that Katarina will lead in a second. Yeah, so how does that look like in practice? In this case, I assign places to treatment and control, individual places to treatment and control. I do block random assignment, meaning I stratify my sample on constituency. That's a complication that you can that you can account for. It's really one line of code, right? Or 2 lines of code. And it's very important that we set what is called a random number seed that makes our assignment replicable across different machines, across different users. And this is how our block random assignment then comes out. Now you see here, we have assigned places with a probability of 0.5, or these are constituencies. So these are postcodes that we have assigned with a probability of 0.5 to treatment and control. You see, that half of them have been assigned to receive ads and half of them have been assigned to control. And so this is basically how to do random assignment using R, and we'll show you how to do that in a second. Now I wanted to talk you through a couple of designs that use simple randomness, that use complete random assignment. Yeah, where you assign subjects with equal probabilities to one of multiple experimental groups. One of them is really the Monga example, which I think is instructive and also well known. It's a experiment that has been conducted on Twitter. As I said, Twitter is quite open to experimentation, with the limitation that the platform changes every so often. Yeah, and the rules of engagement on that platform might also change. In this group, in this experiment, what Kevin did is that he assigned subjects with equal probabilities to 4 different conditions using a 2x2 factorial design. Yeah, in this case, the first factor would be whether a bot which would correct a user on Twitter that would engage in a racist slur would be basically would be engaged in by a bot which is either from the in-group. In this case, it would be a African-American Twitter user, or the out-group. It would be, the in-group, it would be a white Twitter user, or the out-group, which would be African-American Twitter user in this kind of case. So the subjects were all basically white men in this case. And then the second dimension here was whether the bot had kind of a high follower count or a low follower count, which really leaves you with 4 different possible combinations. Yeah, so the bot can either be in-group with a low follower count, in-group with a high follower count, out-group with a low follower count, and out-group with a high follower count. And these are the different predictions that Kevin had for those different conditions. Yeah, he expected the largest effect for groups really, where you would have an in-group sanctioning happening and the in-group bot would have a high follower count. Really the experiment looked a bit like this, right? So you would have a user engaging in a racist slur, and then you would have sanctioning by a bot happening. In this case, the bot was from the out group in this case. And then what Kevin would do is that he would observe going forward if this user would continue to engage in basically racist harassment or racist slurs online. So that is really what was happening there. And we would compare across treatment and control group in this case. It is assigned at the individual level, right? I mean, because what happened is that, using text analysis, automated text analysis, Kevin sampled just a sample of users who were engaging in this type of behavior online. And then at the individual level, half of them, or, in this case, 25% of them were assigned to each of the treatment conditions. And then, in this case, they received this message. The outcome would be how would they behave afterwards. So this is a typically kind of experiment that is assigned at the individual level, because we assign individual users to either receive one message or a different type of message. Different example is an experiment I conducted a while back with 3 co-authors in Bulgaria. And this is really a experiment that was conducted in collaboration with a civic organization, which was or set out to save some of the Black Sea coast in Bulgaria from construction, from illegal construction that was happening there. Basically mafia-related, undertakings. And what we did there is we recruited subjects first into an online panel. So this was a representative sample of Facebook users. We worked together with a polling firm to do that. And then we incentivized subjects. We discussed the question of incentivization before, to enroll into one of two groups. One was basically a Facebook group, which you see here. Yeah. Then there was an email list. They could sign up to an email list or a control group. And both in this case, like on the Facebook group or the Facebook page, and in the email list, they would kind of receive the same information. And there would be information about, like what you could do to kind of save the Black Sea shore. It would be, information about the laws that are being violated there, like the type of activities that the group would undertake, and so on. And that would go on for about 6 weeks. And afterwards, we would run an outcome wave to see whether the information that had been disseminated either online or via email had an effect on subjects' attitudes or an effect on subjects' behavior going forward. Yeah, again, here, this is really individual level assignment, because we individually encourage subjects to either follow the Facebook page or to sign up to receive an email. Yeah, so this is actually quite a common design. This type of embedding an online intervention into a panel study, which also has the advantage that, in the first place, basically subjects consented to basically being part of a study and being part of being studied. They just didn't know the purpose of the treatment. They didn't know that we wanted to study how they respond to being exposed to environmental information or information on corruption that was happening in the country. Yeah. Similar actually design, and these are some of the results here. You see that actually the study had relatively little effects on, for instance, engagements online or discussion online here. Overall, we see some, positive effects, just like slightly on like discussion offline. But if you look at all the outcomes that were measured in the study, we basically find null effects. And we don't find that this type of campaign that was run by this NGO changed outcomes or changed information or changed behavior online. Actually, in a way, a type of similar design has been implemented by Andy Guess and Simon Munset and some of their co-authors, which is actually a really cool study that you should read about. And there, again, they recruit people into a panel study, and then they randomly assign them to 3 conditions. One of them would be to set Fox News as the default browser page, basically in the, on the starting page with whatever the browser would be, or to set HuffPost as a default page, as the home page, for instance, on Chrome, or to control, which is basically in this case, they leave the starting page to whatever that kind of starting page would be on your browser. Yeah, and so here the encouragement is kind of encourage people to change the website they would go to, the landing page, when they open their browser. And that means, and they show that very convincingly, that actually subjects kept on or kind of started to spend more time on those pages. Yeah, so people assigned to the Fox News condition would spend more time on basically the page reading Fox News. Subjects assigned to the HuffPost condition would spend more time, basically reading news on the HuffPost compared to the control condition. And then afterwards, in those kind of post-treatment waves, they were actually tracking, opinions that subjects had, political knowledge, polarization type of outcomes, media trust, and political positions. And what they find is basically they find null effects really on most positional type of issues, which is also quite surprising, but they find some effects on trust in the mainstream media. And so they find that, basically subjects assigned to Fox News or the HuffPost have less trust in kind of mainstream media outlets afterwards, which is also an important finding, basically. But so these are some of those, again, studies where the treatment happens on social media, right? Or social media or online, right? It's not really social media in this case, it's online. But subjects are actually surveyed or embedded in this type of panel style survey. Yeah. We also have some online related outcomes here. For instance, how many times people click on this kind of news sites. Same here, for instance, in my study on Facebook, we have outcomes related to, whether people share, for instance, posts, right? I mean, like whether they like posts on the website, this type of things. It also can be used as, some type of manipulation check, really, right? I mean, like, did we actually really kind of do what we set out to do, which is like have people engage with the type of content? And you see that people did engage with the content. It just didn't, like go beyond clicks and shares. Yeah, there were clicks and shares, but there was no real change in attitudes and behaviors afterwards. All of those experiments, and this doesn't only count for social media-based field experiments, it counts for any type of experiment or any type of study really that attempts to make a causal inference, relies on the three core assumptions that you would have heard at one point or another, which is independence, meaning potential outcomes, potential outcomes are independent of treatment assignment. Yeah, whether you're treated or not tells you nothing about how you would respond to the treatment if treated. Tells you nothing about background attributes, about like which values you take on covariates. Excludability, which means there's no other path to the outcome from the treatment than via kind of receiving the treatment. There's no backdoor path, right? I mean, for instance, in terms of the treatment setting on motion, differential measurement type of things. For instance, you would measure outcomes for the treatment group on Tuesdays and outcomes for the control group on Wednesdays. So both of those groups have to be handled exactly in the same way. There's no other, kind of treatment or kind of thing correlated with being in the treatment group. For instance, I gave you an example before, for instance, being paid. You're only paid if you're in the treatment group. Then in the end, you can't tell whether the reaction that you observe is due to the actual treatment, like for instance, subscribing to a specific page, or it is due to being paid, the financial incentive that you're given. And then thirdly, non-interference. Yeah, and the non-interference assumption is often also known as SUTVA, or the stable unit treatment value assumption, which is a long way of saying that subjects, basically potential outcomes should only be a function of their own assignment. And as you might imagine, while we have to respect independence and excludability in all experiments, independence is kind of being taken care of, hopefully through random assignment. If we didn't muck about with it, yeah, a random assignment leads to the independence assumption usually to be respected or not violated. Non-interference is a specific issue in field experiments, and specifically social media field experiments. And that is for the obvious fact that people interact on social media. So what is the non-interference assumption, spelled out a bit more formally using the type of notation that I introduced? So YID in this case would be the potential outcome that would be expressed based on the treatment that subject I receives, right? I mean, YI1 or YI0, as I said before. Now, YI bold D is the potential outcome that subject I would express based on the assignments that all other subjects in the sample receive. Yeah, so basically, what would my treated potential outcome be if you are assigned to treatment? And, like the other kind of node in the network is assigned to control. And the equality here inherent in the non-interference assumption is that YID equals YI fat D or bold D. And that means that my potential outcome is only a function of my own assignment. It's not a function of the assignment of others in the sample. And that is quite a strong assumption, right? Because it means that subject I is unaffected by the treatment of other subjects. Now, as I said, one of the issues here is that inference or interference between subjects is actually quite common on social media for obvious reasons. And therefore, the question is, what if there is interference or interaction between subjects? For instance, there could be contagion, right? I mean, like, so subjects influencing each other, subjects' behavior spilling over to other subjects. There could be communication between subjects. So we are talking to each other on social media, which is what we do in social media in general, right? We see each other's posts. We share, posts, for instance. So if the treatment is a post, and that post is being shared with members of the control group, we have a non-interference violation. There could be social comparisons. Yeah, I could see what happens to the control group. Somehow that could be displayed to me. Again, there would be a violation of the non-interference assumption. And there could be interference, not inference, but maybe also inference, but interference between platforms, including displacement. Meaning, I mean, take an obvious example. I get banned from Twitter, and I join, one of those platforms whose names I forgot that sprung up in the internet instead. Yeah, and post instead on those type of platforms. And so that means, outcomes might be unobserved. So this would be similar to what we would refer to as displacement, right? I mean, we would think that people kind of refrain from behavior while they just do it somewhere else. And those, again, like kind of behaviors, they're common in all type of experiments, especially in the real world, but they're more common on social media, or there are more opportunities for subjects to engage in them on social media. So what can we do, right? I mean, if potential outcomes are likely to depend on other subjects' treatment status. So first of all, we can expand the schedule of potential outcomes, and we need to redefine the estimator in this case. That means we no longer only have 2 potential outcomes, but we have 4 potential outcomes, or 8 potential outcomes, or 100 potential outcomes, or 1,000 potential outcomes. And you will see that this kind of quickly gets out of hand, depending on how many subjects interact with each other. But on a very basic level, like my potential outcome could be a function of my own assignment, D equals 1, and of my, for instance, network neighbors assignment. In this case, they would also be assigned to treatment. Here, we are both assigned to control. Here, I'm assigned to control, and my neighbor is assigned to, a neighboring node is assigned to treatment. And here I'm assigned to treatment, and my neighbor is assigned to control. And this will then give us different estimators, right? I mean, for instance, we could estimate the effect of all network nodes if we assume that there are only 2 nodes in the network being assigned to treatment minus nobody being assigned to treatment. Right, or we could basically estimate the effect of one of us being assigned to treatment versus nobody being assigned to treatment. But we have to be aware that what we are estimating is not the kind of, effect of one subject being assigned to treatment, but it is the effect of, like the whole network in this kind of sense being assigned to treatment or not being assigned to treatment. What we can also do, and that is especially the case if networks get too complicated or too complex, we could obtain a measure of the network pre-treatment. So for instance, on Twitter, I can actually, like scrape all kind of people that are connected to you on your user profile and assign subjects in the same network together to treatment and control. So everybody who follows each other is assigned to either treatment or to control. This works better in some networks than in others. And Twitter, this could be very, very complex. But if you know that, for instance, there are 2 nodes or 3 nodes that often interact or frequently interact with each other, you can take care of that by kind of assigning them together to one condition or to the other condition. And that is what we refer to as cluster random assignment. Cluster random assignment, which is very common in social media experiments too, for multiple reasons, but one reason being frequent interaction between nodes in a network. And this is basically what I would like to talk now, basically encourage or invite Katarina to talk you through in our practical example. I'll leave the brainstorming for later if we have time about your own social media experiments. Also kind of this could be better done, I think, after we've introduced you also to cluster random assignment in the next session. But for now, we'll concentrate on like how to actually perform individual level random assignment in R and how to analyze experimental data that has resulted from a individual level assignment process. So I would hand over to Katerina for the R demonstration. Yeah, and please, switch over to your R Studio and open the files that are in the Lab 1 folder. Thank you.
Great, thanks a lot. Olga or Hui, could you just make me a co-host, please, so I can share my screen? Meanwhile, while that's happening, you should have all received a link to a Dropbox zip folder that you can download and then extract the files. There is a file called 00 lab installation that contains different packages that you should install. Let me just quickly share what the folder looks like with you. So this is the R file that we're talking about, 00 lab 1 installation. Please run that if you haven't done so already. And then what I would like you to open next is to go into the lab 1 folder, open that, and then open the RMD file called 0.1 lab 1. So let me just go into R Studio. Can you see my R Studio screen right now?
Not yet. We're seeing your folder.
Okay, let me just stop sharing and share again. Can you see my R Studio screen now?
Yes, we can see it now. Thank you.
Perfect. Let me know if I need to zoom in a bit more, if you can see that okay.
Yes, maybe if we can increase the font size a little bit more.
Mm-hmm.
Thank you.
Sure. Is that a bit better?
Yes, it's good. Thank you.
Okay, fantastic. So you should all be opening this file right now, Lab 1 Social Media Experiments. It's an R Markdown file. Don't worry if you've not worked with this before. R Markdown is really similar to a normal R file. So the very first step that I would like you to take is to change the root directory. And the root directory is just where your files are located. It's telling R, okay, look here for the data that we're going to load in a second, right? So the way that you change this is you change this part. So you see for me here, it's set to where my root directory is, which is on my Dropbox. For yourself, you just change that to the location of this 01 lab 1 R Studio file. And you can find that, for instance, if you go into your folder, if you click on that file, do a right click in Windows, look at the properties, you should find the file location there and you copy and paste that. And if you're a Windows user, you'll have to change the backslash to a / in order to get that right. And as a Mac user, I believe you just right click on it and it should copy paste fine in this format. All right. So if you've not used R Markdown before, the way that we can actually run the code, we can execute it, is we can, for instance, just press on this lovely green button, which executes the entire chunk. A chunk is this gray bit of code. And then we've got these kind of headings and writing in between with a white background. If you want to run only a specific line of code, you can highlight that. And then on a Windows computer, click Control-Enter. And on a Mac, click Command-Enter in order to execute that single line. And get working directory is just a way of checking, have we reset that correctly? So in my case, yes, that's the case. This matches this. So please do this first. And if you've got any problems with this, just send Florian or myself a message in the chat, and we'll be able to allocate you to a breakout room to help you with this. Great. So the next step is always loading packages. If you're not familiar with R, packages are kind of tools that help us do certain things in R, for instance, running certain functions, organizing our data. In this case, we're going to use the randomizer package that Florian talked about earlier in order to do random assignment. So again, just click on Run Current Chunk, and we've got all these different packages loaded in R now. The third step is reading in our data. If that has worked fine, you'll see here in the environment that our data set has loaded. And this data set, we're going to have a look at this in a second, is the data set from Kevin Munger's treatment effects on the tweeted experiment that Florian introduced in his lecture just now. So let's have a quick look. Actually, before I do that, I'm just going to pause for a second and ask anyone who's got a problem with loading this in or getting to this step to just post a quick message in the chat so that someone can assign you to a breakout room with Florian if you need any help with this. Okay, so let's have a quick look at the data together. So the first thing is we're just going to print the first 6 rows of our data frame. And as you can see here, rows are individual observations. So those are individual Twitter users who got assigned in the Kevin Munger experiment. And as you can see here, some of the columns are called treat F, in-group, high followers, anonymity, log followers, and then the racism scores post-treatment. My first 2 questions for you are, what are these columns doing, right? So what are, for instance, our outcome variables here? Can anyone just unmute yourself if you feel comfortable or post it in the chat? Tell me what you think these columns are. Racism scores, racism scores. Okay, a bit of shyness, that's fine, no worries at all. We'll also go into breakout rooms in a second, maybe we'll be a bit more comfortable talking to each other then. So these are the, also, Jaran, would you like to come in?
Yeah, I guess these racism scores post and pre is measured pre-treatment, post stands for measured post-treatment, and I guess 1 WK is the outcome measured 1 week after the intervention, and let's say racism scores pre to MON stands for the outcome measured 2 months before the intervention, as far as I can tell.
Yeah, that's great. Thank you so much. That's exactly right. And here, racism score, just to give you a bit of like context, what that means is the average daily use of racist slur words, right? And as Jaran rightly said, one of the things that we will be looking at in our code in a second is this first outcome variable, the racism score, so the average daily use of racist slurs 1 week after the treatment intervention. And then as you can see in the data set, we also have this 2 months after the treatment intervention, 1 month after the treatment intervention, 2 weeks after the treatment intervention, right? So they're measured at different intervals, and we might be interested in, for instance, if treatment affects decay over time or how they behave. Anonymity is a measure of how anonymous a Twitter user is. So this is a pre-treatment covariate, and it measures from 0, 1, or 2 how anonymous exactly a Twitter user's profile is, using, for instance, measures such as, does the Twitter profile have a profile picture? Does it have an actual full name, first name and last name included in it? And the way that's coded in here is 2 is the most anonymous, 1 is it has some identifiable information like a picture or the name, and 0, it has a picture and a name associated with it, right? The log followers is just the number of followers, the log of the number of followers that an individual Twitter user has. Okay, let's have a quick look at maybe the most important variable or column in this data frame, the one we might be really interested in, which is treat F. And that gives us the treatment assignment. And there are 5 overall conditions in the Kevin Munger experiment for treatment arms, like Florian explained, and the control group. And the way I've printed this here, hopefully, is kind of easy, intuitive to understand. 0 is the control group, 1 is the treatment condition, where you get an in-group bot, so a white male bot with a low number of followers. Treatment group F equals 2 means you get an out group member, so a black male presenting bot with a low number of followers. Treat F3 is an in-group, so white male bot with a high number of followers, and 4 is an out-group bot, so a black male presenting bot with a high number of followers, right? And we can see that individuals are fairly evenly allocated between these different treatment groups. Okay, so let's go to how we actually conduct random assignment in practice. And as I've said before, we are doing this using the randomizer package. And in particular, it's 2 main functions called simple_RA and complete RA. Let me just show you, and please follow along with this in your own R script if you can, what happens when we do this. So let me walk you through what we're doing here. We're setting a seed. We're then creating a new variable with the mutate command from the dplyr package. We call that new column or variable assignment simple. We then say, okay, conduct simple random assignment on the overall number of individuals that are the length of this data set, so the number of rows in our data frame. And we want to have 2 treatment arms. And automatically randomizer then recognizes, okay, we've got 2 treatment arms. So with a probability of 0.5, randomly assign, using simple random assignment, this number of individuals to these 2 treatment arms. And if you look at what this does, we see, okay, we've now got 2 treatment arms, one called T1, one called T2, and we've got 126 individuals in the first one, 117 in the second one. What happens with, instead of using simple random assignment, we do complete random assignment. So as you can see here, the only changes I've made from the code above is I've called this a new variable, assignment complete. And instead of conducting the function simple RA, I'm using the function complete RA, right? All the other things remain the same. The number of individuals we want to assign and the number of arms is still 2. However, the numbers are now quite different, right? You get 122 in treatment group 1 and 121 in treatment group 2. Why is that? Because when we use complete random assignment, we're saying, okay, assign the specific number of individuals to one of the treatment groups. So we get kind of slightly more balanced, by definition, treatment groups in terms of size between the different treatment arms. One more kind of question, why do we need to do this, set a seed? Let me quickly show you what happens when we don't. Okay, so I didn't set a seed here. Let's do it again. The numbers are different, right? So what happens when we don't set a seed is that if someone else wants to reproduce our code, our assignment in the future, they would get different assignments, obviously, on every turn, right? So by setting a seed, we're trying to make this assignment the way that we did it, the random assignment, reproducible. So it's always a good idea to do that and to run that together with your code when you do it. Are there any questions on this before we move into an exercise?
Nothing so far.
Okay, so what I would like you to do next is I would like you in breakout rooms with groups to recreate the random assignment from the manga experiment. So the first thing you want to think about is how many groups do we need to assign to? Remember, in this code, we assign to 2 treatment arms or 2 conditions overall. How many did we have in the manga experiment? It might be helpful to look back to this table up here. Are you going to use simple or complete random assignment and why? Should you set a seed, yes or no? And bonus, can you actually name the treatment and control groups? So I'm going to give you around 10 minutes to do that in your breakout groups with other individuals. Remember, if someone, for instance, has problem accessing our studio at the moment, it would be really great if, for instance, someone in your group has got it working to this point that they just share their screen and then you kind of group code together. That would be the best approach. Are there any questions about this exercise? No, so great. In that case, it would be really great if we could move into breakout rooms for around 10 minutes. Again, I think similar number of individuals per group as before would be great.
Yes, I will assign everyone to the breakout room now. Please run your R code to practice with the questions that was posted.
We're just waiting for Katerina to join us again.
Yes, I think everyone's back.
Yeah, great. Do you want to continue? You're still on mute.
Yes, thank you. Great. So I hope that went okay. I think in the groups I was in, I was very impressed with your work and your coding skills. So that's fantastic. Just to show you really quickly, can you still see my screen all right?
Yes, we can see it.
Perfect. What we want to do is to set a seed, obviously, right? So it's reproducible. And then we want to use complete random assignment to 5 conditions, 1 control and 4 treatment arms. And we can name them using this handy conditions option to control T1, T2, T3, and T4. And if we do this, we run this, we'll see that these are fairly balanced. We get 5 groups, and that's looking pretty similar to the actual assignment in the Munger example. So well done if you got this far. Don't worry if you didn't, we'll share the solutions code with you after the session today, so you can do that and go back to that in your own time. Just a quick note, if you're really struggling to get R going for whatever reasons, there's also an HTML file, so one that has this little Google icon in the folder lab 1 that's called solutions. If you want to follow along with this, you can't get R working, you can access that there. Was there a question in the chat?
Yeah, there's one which was about the random number seed. So what should that seed be?
It doesn't really matter, to be honest. I think it should just be consistent. It doesn't really matter. It's the short answer. It's just important to set one. Okay.
Could be your favorite number if you
want. Exactly. It's just important not to change it later on, yeah? Like to kind of keep it and then share that same seed, the exact code you did to do the assignment with any kind of reviewers or other peer, other researchers, etc. Okay, excellent. So let's quickly look at some analysis. Florian, how much time do we have left for this?
About like 15 minutes.
Okay, great.
10 minutes.
Yeah, perfect. Okay. So let's look at how do we actually analyze the data from the Munger experiment. So the first thing we're going to do is just recode the treatment as a factor variable. Yeah. This is just so that we tell R, okay, this is actually not a number that ranges continuously from 0 to 5 or something like that. Please treat these as different categories of treatment groups that we want to see the results for in our regression analysis. Okay, and then the first thing we want to do is we are going to look at, okay, what's the effect of that treatment assignment on the racist slur scores 1 week after the treatment intervention. And we're also going to include in this linear regression model the log number of followers, which is a pre-treatment covariate, the racism scores for the individuals 2 months prior to the treatment, and the data we're going to use is the data set that we loaded in. We're using robust linear regression models, robust standard errors, and then we're taking the summary of this model and assigning it to this object that we've just called week1_RAC, but you could call this anything you want, yeah? Okay, so let's see what happens when we do that. Okay. So by just simply putting the name of this object that we've just created, and we're going to print it below our chunk. And very helpfully, R tells us again, okay, look, this is the model you actually ran, right? So here we're seeing results for the daily use of racist slur words 1 week post-treatment as a function of the treatment assignment. And here what we get is, because this is a factor variable, the very first part of that is the control group, right? So we're always comparing assignment to one of the treatment groups compared to the control. And what we see here, of course, mirrors exactly the results that you will have found if you read the Munger paper, or if you've come across this in the past. What we find is if we look at treatment F3, yeah, so this row here, sorry, I hope you can see that okay. We find that assignment to the third treatment arm, which if we think back, so if we scroll up a bit, we go back to our table, what was this treatment group? Okay, this was if you were assigned an in-group bot, so white male bot with a high number of followers, then this significantly reduces your use of daily racist slurs 1 week post-treatment. And by how much? By around 0.26, that type of reduction. Is that a lot? One good way of thinking about that would be thinking about, okay, how much is that in terms of a standard deviation in the outcome? And we can just quickly do that. And we see it's around 0.36 of a standard deviation in the outcome. So that's a fairly sizable effect. Think about it, yeah? So fairly, what do we think is happening here? Getting assigned to the white male bot with a high number of followers compared to nothing, compared to the control group, reduces your daily use of daily racist slurs on Twitter by around 1/3 in a standard deviation. Okay, so a fairly interesting effect. However, if we look at the other treatment groups, remember Kevin Munger also had some expectations about what happens if you get assigned an out group, for instance, bot, but who has high status, so a high number of followers. That should also lead to a reduction in the daily use of slurs. We see that these don't have significant effects on that outcome variable, right? The only treatment compared to the control that does something to this outcome seems to be this in-group white male bot who also has high status, so a high number of followers. Okay. I'm going to pause here quickly. Do you have any questions about this at all?
Yes, none so far.
Okay. Florian, do you think we have time for that exercise? Yep. Okay. So as you can see here, very quickly in this model, we might also be interested in how this varies. So this treatment effect might vary for different subsets of Twitter users. So as we've said, pre-treatment, we have these anonymity scores. So people who share personal information about themselves, like a picture and their full name, versus people who are completely anonymous on Twitter. And we might be interested in if this effect of the treatment on the outcome varies according to what kind of anonymity score you have, how much information you're sharing about yourselves on Twitter. And what Kevin Munger's expectation was is that if you are more anonymous, maybe this treatment will have less of an effect. So kind of sanctioning of racist slurs on Twitter is going to be more effective if you're directly exposed with your identity, right? Like if you shared your name, you shared your picture, someone's sanctioning you, telling you, look, that was a racist slur, you shouldn't use that, should have a bigger effect on you than for someone who's not sharing that kind of information about themselves. So what I would like you to do next, again in the same groups, is try and think about how you would model, how you would try and estimate treatment effects for the subset of non-anonymous users. So users who are sharing some information about themselves on Twitter. And again, think back, this should be directly kind of reproducing something similar to this. So we're looking at a subset of users and it should be related to the anonymity score. And I would like you to write code for that and then interpret what you find. You've got around 5 minutes to do that in your groups.
Yes, so you will be assigned to the breakout room now. It will be your O group for the last exercise.
Okay, we're back. That was a short and sweet breakout room. I hope you all got to talk to each other a bit about how you would do this. Just to really quickly show you the way that Kevin Munger does this in his paper. This is direct replication code. You can also find from his website if you're interested, is to say, okay, actually, anonymity is ranges from 0 to 2, so 0, 1, and 2, and 0 and 1 are users who are not that anonymous, who've shared some information about themselves. So we're gonna subset it to those individuals who've got a lower than 2 anonymity score and look at the results for this subset of individuals. And what do we see? This effect is actually slightly smaller, actually insignificant for this subset of individuals, which is at odds with his initial expectations. I also, in the group I was in, there was a discussion, wouldn't we better model this through interaction effects? I think that's a great idea, and I would encourage you to do that. The way I'll share the solutions code with you after the session today, so no worries if you can't kind of copy along right now, just kind of look at the screen and bear with me, is you could recode the anonymity variable as a factor, right? Because at the moment, the way it is coded just comes up as a continuous numerical variable. And then we think about what happens when we interact this with the treatment variable, right? And because there's not that many individuals in each category, this wouldn't come up as significant if we modeled it that way, right? But the way it is included in the Munger paper, if you read this, is just what happens when we look at different subsets of individuals, when we look at the most anonymous users compared to non-anonymous users. Do the treatment effects change? And they don't change in the direction that we would expect, meaning that actually the treatment effects aren't kind of bigger for the most non-anonymous users who've shared some information about themselves.
I mean, that's quite interesting, right? And because the groups don't seem to be kind of exclusive here, right? So, so how I would have defined it, I guess, would be kind of anonymity would be, smaller or equal to 1. If, above, we would have defined non-anonymous users as kind of having a score larger than 1. So I think that would be another kind of.
I also saw someone suggesting, we should be more conservative. Non-anonymous should only be users who score 0, for instance. I would always encourage you to try stuff like that out. I don't think there is a kind of black or white, this is the right way to do it. This is the way he presents it, like in his paper, but I think there's definitely an argument to be made, to be said, actually, we should only conservatively classify individuals as non-anonymous when they've both shared their name and the profile picture, in which case they would score 0, right? So
yeah, no, exactly. I think it's one thing that you should definitely pre-register if you conduct this type of subgroup analysis going forward.
Yeah.
I mean, it's actually one of the, I think, results of the paper that hasn't stood up going forward. This type of, I think Kevin has replicated it, and he found the opposite actually in a kind of a more recent paper of his.
Great. Well, thanks so much for following along with this. Again, we'll upload the solutions code after the session today. And you're also very welcome to just look at the HTML file if for some reason you had problems kind of loading in files into R.
Great. Thank you so much, Katerina, for leading on this. And thanks a lot for following along and coding along. And for the good questions also that we got in the breakout rooms. I would say we're taking a 5 minutes break so everybody can kind of get another cup of coffee or some water, and afterwards we'll reconvene, and I'm going to talk about what we should be doing if we are in the unfortunate position where we can't assign individuals to treatment and control individually, but we have to do that at the network level or, you know, some geographical level, which is quite common in network or social media based experiments. So see you again in 5 minutes, and thanks again to Katerina. Fantastic job. Thanks. Hello, everyone. I just wanted to give you an opportunity to ask questions, actually, if you have anything that you wanted to talk about from the past sessions, anything that you have thought about, or, you know, over your coffee break or your coffee that's on your mind before we go on. Yeah, no questions. Maybe after the last session, I hope. Regarding budget. So what budget do you usually have to take into consideration when doing a field experiment? It's a good question, and I think there's no straightforward answer to that, right? It really differs a lot. I think, you know, the experiment that Kevin conducted over, you know, like that you just saw, it's probably conducted on a budget of like $0, right? I mean, like and lots of hours that he invested. You know, basically using those, they're not really bots, right? I mean, they are researcher directed accounts in that kind of sense. But I don't think that cost him anything in terms of money. He was a PhD student at the time when he conducted the experiment, so he would have invested many hours, but there wasn't any financial investment there. I'm going to talk about in a second about a digital ads experiment that I conducted together with Asli Unan, who's a PhD researcher at King's College London, and Peter John, who's professor of public policy at King's. And that required, like more extensive funds, because those were the, we wanted to look at the effects of paid ads. We didn't pay that ourselves. We actually partnered with an organization called Vote for Your Future, and they paid for their ads. And the only thing we did was randomly assign those ads. But I guess the investment went into kind of was probably around £10,000 that was spent on the experiment that I'm going to show you in a second. But it really matters. The scale matters, and I think the more, once you get into cluster assignment, which we're going to get into now, often those experiments are a bit more costly, and because you need to cover a much larger share of users or areas. But generally, like it depends whether the treatment is costly, right? I mean, so whether you have to buy, like for instance, ad space, whether subject recruitment is costly, right? I mean, whether, for instance, you need to pay subjects for their time, or encourage them with a specific type of lotteries or this type of interventions, or whether you're treating subjects on social media, as for instance, Alexandra Siegel did or Kevin did, in this sense. So it can really range from nothing to quite expensive. I would say field experiments in general can be less. They're usually less expensive if you find a partner organization to implement them together with, because they usually volunteer their time and they pay for the treatment materials. So, for instance, in my own field experimental work, I did a lot of work with political parties or NGOs, and usually the treatment administration or the treatment itself would be, paid for by the partner organization. And then it depends on whether your outcome data collection is costly or not. And that depends again on whether you, for instance, you look at outcomes that can be measured on social media that are usually free to get, or you're going to, for instance, obtain survey data, which is more expensive. Yeah, and once you get into kind of multi-wave panel studies, you're easily into the kind of tens of thousands of pounds or euros. So about MTurk, so I'm not using MTurk myself or any of the kind of crowdsourced platforms, because they're mostly used for survey type of experimental work, which I do less of. So I'm actually almost entirely kind of a field experimentalist doing work basically in the field. If you could recruit people, I guess MTurk would be less likely to be used for actually kind of really kind of recruiting people into your own panel. I think that would also be probably against their kind of usage rules. Usually you use MTurk, to give people a specific task, coding task, or specific kind of, like survey that you administer online. So it'd be less suitable, I think, for field experimental type of work. That's a good question. Thanks. So let's get into cluster random assignment. So first, I wanted to define what clustering actually is, right? So clustering is what happens when subjects are nested together in a, could be a social space, like a network, could be a physical space, like a neighborhood, for instance, or it could be a Zoom room, like us together at the moment. We are nested in a, in a cluster together for the purpose of interaction. For instance, we interact with each other, so our potential outcomes are probably not independent, depending on how much you talk in your, like in your breakout rooms. So we are nested together in some type of social or physical space, and that social physical space is meaningful, right? Meaningful in that it the outcomes are correlated in that, to some extent, in that space. So now what cluster random assignment means is that all subjects that are together in that social, physical space, they are also assigned together to the same experimental condition. That means everybody who's in the same Zoom room, to take our example, will either be treated or untreated. And there will be no kind of, Zoom breakout room. In this case, if we assign subjects by Zoom breakout room, where, you know, like one subject would be treated and the other subject would be in control. They would all either be in treatment or in control. Yeah, imagine, you know, like the treatment would be either, you know, Katerina giving competent advice or me giving incompetent advice. It might have happened. You know, so you would all either get Katerina as a treatment or me as a treatment, or nobody. Yeah, which is not what happened, of course. So now cluster random assignment. Why is it so important to social media experiments? It's generally often used in field experiments, not so often used in survey experiments, right? But why is it so important for social media-based field experiments? Well, because there are platform constraints where assignment cannot be done at the individual level. For instance, you know, Facebook Ad Manager, which is also the same as Instagram Ad Manager, only allows targeting of users by geographic area or interest. Geographic area could be kind of 1 kilometer wide radiuses, or it could be the smallest level at which you can target in the UK is the postcode sector, which is the level above the postcode. It's the first 4 digits of the postcode. So that's one reason, right? I mean, these are practical constraints. You can't target at the individual level. So we take the kind of the smallest level just above the individual level at which we can target. The second kind of reason for why you might want to cluster or use cluster random assignment is because we think that the non-interference assumption might be violated in meaningful ways within that specific cluster, and therefore our estimator might be biased. So that might be true if, you know, as we discussed, like at the very end of the first part, subjects talk to each other, or they, you know, behaviors spill over. They basically, you know, they imitate each other, this type of things happening. Their learning depends on each other. Yeah, and therefore kind of control and treatment would no longer be, you know, really separate. So the control group would get some kind of partial treatment, spillovers. And therefore really kind of, you know, potential outcomes in those clusters are a function of the treatment assignment of other subjects. And it's specifically a concern, right? I mean, like if your control subjects would be treated, they would receive some share of the treatment. And then what we do is basically we receive everybody who is located in that space, you know, where that allows them to kind of talk to each other or kind of interact with each other, which could be a social network, a part of a social network, could be your followers in a social network and so on, together to either treatment and control. And therefore we ensure that everybody is either assigned to treatment only or to control only. And those people basically, they you know, there's no spillover from treatment to control, or the potential for spillover from treatment to control is reduced. It means also that we need some type of spillover model, right? I mean, we need to determine in our heads, or based on other kind of studies, on pre-treatment data, on other kind of things, in which kind of contexts treatments are likely to spill over and in which contexts they are not. I can give you an offline example for that. For instance, quite a lot of GeoTV experiments assume that treatment spills over within households, but not between households. That's the spillover model. Yeah, we allow for spillovers between households, but not between households. So I give you a more kind of quantitative example here. So imagine you have, for the sake of it, only 12 subjects, and to keep it simple, and they are located within K equals 4 networks. And it means that your, you know, total N equals K times 3. Yeah, so you have basically 3 subjects in each of those 4 networks, yeah, assuming that they're equal size, which is also quite important for clustering. Because if they're not equal size, if their size differs significantly, this could lead to bias, especially in smaller kind of samples. I'm going to talk about what you can do about this in a second. So what we can do, so for the sake of, you know, like our example, we want to randomly assign 2 of those 4 networks or clusters to the treatment group. Yeah, that means that the total number of possible random assignments would be n factorial over m factorial times n minus m factorial. A factorial would be, in this case, you know, like multiplying each number in the row of numbers, like for instance, 3 factorial would be 3 times 2 times 1. You might know that from math in high school. Yeah, and in this case, where we have like our 4 clusters, and we want to assign 2 of them, exactly 2 of them to treatment, it would be 4 factorial, right? I mean, and it would be our overall number of clusters divided by 2 factorial, which is the number of clusters assigned to treatment, times n, which is again kind of our whole sample of clusters, which would be 4, minus the number of treatment clusters, 2, would be 2 factorial. And that is a relatively small number, right? It's 6. So there are only 6 different ways in which we can assign exactly 2 of those networks to treatment. And these are not many iterations actually through which we can go to. Now assume, for the sake of argument, that there wouldn't be any kind of, reason for why we would want to assign subjects to treatment by cluster. And, we could just assign our 12 subjects using complete random assignment. So what would happen then, right? In this case, again, following the same, formula, we'd end up with 12 factorial divided by 6 factorial times 6 factorial. Yeah, 12 subjects overall, 6 subjects, exactly 6 subjects in the treatment group, exactly 6 subjects in the control group. And that's a much bigger number, right? I mean, it's 924 ways of assigning subjects to treatment and control. That also implies that sampling variability in this case will be much higher, than in this case, in almost all cases. There are some instances where this would not necessarily lead to higher sampling variability, which I'm going to talk you through. But, there are only basically 6 ways of doing that. So just to kind of to think through the implications of what that actually means for your design. Yeah. So here I have, this is just a formula for the true standard error under cluster random assignment. The true standard error means the standard error, like that is truly out there, assuming that we are aware of the full schedule of potential outcomes. Yeah, for each subject. In this case, we can know about the covariance here because we assume that we're living in a world, we are basically in a position where we could know everybody's YI1 and everybody's YI0, which is not true in the real world. In the real world, we'll have to make an assumption about the covariance. And usually what we will do is we'll make a conservative assumption about that. But what you see here is basically what really goes into that, standard error, so into this true standard error. And what goes into it is the cluster size, K, but also the individual level N, which is in this case N and M. What you have here is the average untreated potential outcome in your cluster. That means that's really kind of the cluster mean. In this case, this is basically the cluster mean for clusters assigned to control, and that's the cluster mean for clusters assigned to treatment. In this case, K, as I said, is the number of clusters. And what you see here is that really kind of the standard error depends quite heavily on the numbers of clusters in your experiment. It's somewhere, so your standard error using cluster random assignment will be somewhere between your standard error, which you would get if you had just used complete random assignment, and if you would just have assigned everybody at the higher level. Now I want to go into giving you an example that's actually taken from Gerber and Green's amazing textbook on field experiments, which is published in 2012. I recommend you buy it. Which gives you 2 examples of when clustering comes with a kind of a high penalty and when it comes with a relatively low penalty. So the first example that I'm going to give you, in this case, we have 12 units, but they work with classrooms, but it could be kind of, our example continued if you want it. In the first example, we have high variability of sample means between clusters. Yeah, so what you have here, or like if you look at your potential outcomes, is that like this would be your, basically here would be your schools. In this case, this would be the clusters, and we have 4 clusters: A, B, C, and D. And the classrooms would be kind of our, our lower level unit that is nested within the school. And what you see here is that the cluster, for instance, cluster A, is quite predictive of the potential outcomes that you see here of your subjects. In cluster A, subjects have relatively, let me just go, sorry, 1 second. Yeah, in cluster A, subjects have relatively low potential outcomes. Yeah, while in cluster D, their potential outcomes are higher. And so there's a association between in which cluster you are and basically the potential outcomes in your sample. And that is exactly a case, here you basically have the classroom level potential outcomes, and here you have the cluster level mean potential outcomes. Again, looking either at the outcomes here or the cluster level means, you see that basically the cluster is very predictive of potential outcomes. And that is a case where clustering would be, you'd incur a higher penalty, meaning it would be costly for you. And that is because, if you would plug in these numbers into our standard error formula, then you would see that this would lead to a higher standard error. And what you see here is basically that there is more variability in potential outcomes between clusters, between cluster D, for instance, and cluster A, than within clusters. As most of our variability really comes from the cluster. And this is often the case, unfortunately, in field experiments, and it's often the case also in social media type of field experiments, if they are based, like on your specific network, if your cluster is, for instance, a network, and the cluster itself is meaningfully associated with the outcome, which is really what is often happening. Now I'm going to give you an example where this is not the case. In this case, well, your clusters are actually not predictive of the outcome. You have quite a bit of variability in potential outcomes within the cluster, within school A, or within school B, or within school D. But it's not the case, like that outcomes in school D are, systematically higher than outcomes in school A or school B. And that means in this case, most of your variance comes from the classroom level, your lower level, and not, basically it's not predicted by your cluster. So there's higher, basically intra-cluster variance and lower inter-cluster variance. And in this case, clustering would actually not incur a high penalty. In this case, your cluster level design would be as powerful as your individual or complete random assignments that you could use. Could that ever be possible? The answer is yes. For instance, one example would be if you randomly assign your subjects to clusters. If I randomly assign my subjects to clusters, then per definition, their potential outcomes would be independent of the cluster in which they are in. And then I administer my treatment to the clusters. In this case, I wouldn't really incur much of a penalty here. And for like practical reasons, sometimes I might want to do that. But if I'm not in control about clustering, if I take clusters, like really from the internet, like from, as they occur in the kind of natural virtual world, then usually my clusters will be predictive of potential outcomes. And that means that I will incur a penalty to clustering, and that penalty comes in terms of like an inflated or increased standard error. So that then leads us to the question, what to do about it? How can we account for clustering at the analysis stage? So you might have heard that before. And as a general rule of thumb, that is what I would recommend. Yeah, always or almost always cluster your standard errors at the level at which the treatment is assigned. Meaning, if I assign my treatment at the postcode sector level, but then I have, postcodes nested within those postcode sectors, and I have individuals nested within those postcodes, then what I should be doing is cluster my treatment, basically my standard errors at the postcode level, at the level at which I assigned postcodes and subjects to treatment and control. Yeah, always cluster at the level of assignment. It really follows this kind of mantra: analyze as you randomize. Yeah, at the level at which you randomize, you cluster your standard errors in the analysis. That means, in different example, if you assign subjects within Zoom rooms to treatment and control, then you need to cluster your standard errors at the Zoom room level. So basically you need to cluster. If you don't cluster, there will be a bias in your standard error, and it will be a downward bias in this case, in almost all cases. And so as I said, so the exact penalty you occur for cluster random assignment depends on the variability of the cluster level means. Yeah, whether there is a lot of variability between, like in outcomes between clusters, as opposed to outcomes within clusters. And this is often summed up in this statistic that we call the intra-cluster correlation, or ICC. You might have come across it at one point. What the ICC does, it compares the variance within clusters to the variance between clusters. It ranges between 0 and 1. Yeah, if the ICC is 1, that means that subjects within clusters do not vary at all, from each other. And in this case, your cluster level N will be equal to the overall N of the study. If it falls somewhere in between, like a low ICC is always good. Yeah, because it means that most of the variance is really explained by differences between individuals. It's not explained by differences, between clusters. And that means that your study, is powered better. An implication of that is also that usually, so if the ICC is relatively high or higher, then you gain more from including more clusters in your experiment than from including more individuals per cluster. And so if you can add more clusters, for instance, if you can add more, for instance, postcode sectors to your kind of social media ad-based experiment, that's more effective than adding more postcodes within that postcode sector. The exact kind of implications here, I would recommend that you engage in simulation type of power analysis that could give you more exact answer to kind of how big that or small that penalty would exactly kind of turn out to be. But as an intuition, usually increasing the number of clusters in most cases will gain you more statistical power than increasing the number of individuals within clusters. And so we can, for instance, look at that together if you wanted, very kind of simple example here. Just going to switch over. One second, let me just share my screen. Yeah, so this is a, can you all see the, no, you can't, right? 1 second. Can you all see the eGap Shiny app now?
Yeah, we can see it.
Okay, fantastic. Yes, in this case, we have a cluster design. And I take a binary dependent variable, for instance. What you see here is the following. Yeah, so I've assumed here this is wrong, unfortunately. This needs to read 7 percentage points, yeah, not 0.7 percentage points. This is a 7 percentage point treatment effect here that I assume. I assume an intercluster correlation of 0.5. Yeah, this is basically, there's a lot of, like the clusters are doing quite a lot of explaining here. Yeah, in terms of outcomes or potential outcomes between subjects. I have 200 arms clusters per arm, meaning because it's a 2 arm design, I have 400 clusters here, and in each of basically those clusters, I have 10 subjects. Yeah, so this is basically the basic design here. What you see here, you have the you have power on the y-axis, and then you have the number of subjects on the x-axis. You see that our cluster design, which is here in green, and these are different basically simulations coming out of it, is less powerful, significantly less powerful, right? I mean, than our equivalent individual level design. Yeah, so we're never gonna get to kind of 80% power here if the ICC is really kind of as high as 0.5. Now, what I wanted to show you is what happens if I actually lower the ICC, for instance, to 0.1. Yeah, in this case, I still incur a bit of a penalty. Yeah, but the penalty is not as large as what I incurred before. What I could also do, for instance, if I increased the number of clusters per arm, like to double. In this case, I would have 400 clusters per arm. Again, I get quite a bit of gain here from doing that. Yeah, so what I would really recommend is use one of those, like power, apps, simulators, packages that are available now. The good one is Declare Design, which also has a really nice, a bit more complicated, takes a bit more time. So that's why I'm not using it right now. But it has also a nice interface, a nice shiny app coming with it. It's the Declare Design Wizard, done by some of your colleagues at the Berlin Social Science Center. And simulate this kind of things if you can. Yeah. So really takeaway here is that clustering usually comes with a penalty. It comes with a larger penalty if the clusters are really predictive of outcomes. Let me just get back to sharing my slide here. So, right, now some complications beyond that. Yeah, I mean, takeaways was like kind of if you need to assign, like if you do cluster random assignment, which might be necessary either because, the platform or the social media platform doesn't allow you to do individual level assignment. Otherwise, individual level assignment is almost always preferable. Or because you really anticipate that the non-interference assumption that I talked about before will be violated in severe ways. Then, like you should cluster your standard errors at the level of assignment. Sometimes this type of, your estimator can still be biased, fortunately. And that is because if clusters are of vastly unequal size, so everything we have done so far assume that, clusters are of approximately the same size. Or at least, it's not the case that, one postcode sector would have like 1,000 postcodes in them, and the other postcode sector would have like 10 postcodes in them. So I'm talking about, like this kind of scale of unequal, size here. And if that varies with potential outcomes, yeah, meaning that the treatment might be, for instance, much more effective in smaller sectors than in larger sectors, then your difference in means estimator could be biased, your ATE estimator. So the good news is that this bias disappears if the number of clusters increases. So if number of clusters is like close to like your hundreds, then you're likely to be fine. In smaller samples, say we're dealing with like 20 clusters, 30 clusters, you'll be biased. In this case, we need to switch the estimator to something which is called the difference in totals estimator. And what we're doing is we're going to go to we're going to estimate outcomes at the cluster level rather than the individual level. if you're interested, I mean, most of this discussion you can find in the Gerber-Green textbook. For instance, how like to define the difference in totals estimator. There's also another slight complication, which is that sometimes we would need to cluster both the level of assignment. So there's one big rule, which is like you can never cluster below the level of assignment. It's also not clustering, right? I mean, but you should always cluster at least at the level of assignment. And in 9 out of 10 cases at the level of assignment. There is one case where you might have to cluster both the level of assignment, which is if you have sampled a population you sample from a larger population. And so there is a sampling reason for clustering, not an assignment reason for clustering. There's a paper by Abadi et al., which makes the point, I think, quite forcefully. You can see more kind of simulation-based take on this also by Blair et al. And they basically just confirm the point made by Abadi et al., which is that in some cases where we have design, like sampling design-based reasons for clustering, not random assignment-based, but sampling-based reasons for clustering. For instance, we have randomly sampled some users from the network, and then we have randomly assigned, and that was based on, for instance, geography. Yeah, we have taken, there was some kind of stratification in the sampling that we have done, and then we have taken those users and then assigned them to treatment and control afterwards. If we want to say something about the kind of the larger population of users, we want to get at some type of population average treatment effect, not only a sample average treatment effect, but a population average treatment effect. We want to generalize to the population. In this case, then we might have to cluster both the level of assignment. And if you want to say something about the population. There is also one further complication relating to outcome measurement, which is that with cluster random assignment, the level of outcome measurement is by definition or should be below the level at which random assignment is conducted. If it's at the same level as assignment, it's no longer clustered, right? I mean, in this case, you just basically, it's individual level assignment at the level of outcome measurement. The problem arises if the lower level of outcome measurement doesn't perfectly fit or match the higher level. Sometimes this can happen, say, using constituencies, parliamentary constituencies as your assignment. Basically cluster. You cluster randomly assign at the constituency level, but postcodes, fall into different constituencies, which is actually the case in the United Kingdom. Therefore, a postcode is no longer perfectly nested within that higher level at which you conduct the assignment. And therefore, you'll run into problems at the outcome measurement stage, because then you will have to allocate parts of that sector. You'll have to do weighting, and it's not impossible, but this will definitely complicate your analysis. And I would recommend you avoid it if you can. At the design stage. So the more we can kind of take care of these issues at the design stage, the less we have to do, or have to do modeling wise at the analysis stage. And everything that we're going to do, maybe we're going to get to a stage where we avoid bias, but it will definitely be costly in terms of efficiency. It will be costly, we'll be introducing noise into the estimator. If we have this type of issues with measurement, it's a measurement issue, right? I mean, it's nothing specific about experiments here. You would encounter exactly the same kind of issues if you were running an observational study and you would have a hierarchical model. So it's, I would recommend, just in practical terms, and that's also going back to some experience, having conducted some of those experiments and having done pilots where this was not always the case, it's important that outcomes can be matched unambiguously to assignment and that the boundaries do not overlap. So I wanted to give you some practical examples, like of, social media based field experiments that have been assigned at the cluster level. So there's this one study that Alexander Wutke and I have conducted, which looks at the effects of democratic persuasion performed by legislators, in this case, members of the German parliament, in their basically interactions with constituents. And this was based on an online town hall experiment that we conducted on Zoom, where pretty simple setup, 2 conditions, 1 democratic persuasion town hall, 1 kind of standard town halls where legislators would engage with constituents as they always would on the topic. This was on the topic of COVID-19. If you're interested, I'm very happy to email you the working paper, the conference paper at the moment. So the basic idea here was that, what would happen if elected representatives would make an explicit case for the democratic system of government while acknowledging that democracy isn't perfect, especially in the context of the crisis. And so what we did is we recruited a politically heterogeneous sample of German citizens via quota sampling on Facebook. So this is actually, first of all, the subjects are recruited from social media via social media ads to participate in one of 16 Zoom town halls with elected state and federal representatives. There were 8 politicians that collaborated on this experiment. And they were recruited from 5 parties. 8 of the politicians were opposition politicians, 8 were representing government parties in Germany. Those town halls were advertised as opportunities for citizens to discuss with legislators about COVID-19. Basic setup is, again, you have subjects recruited via Facebook into a pre-treatment wave, online panel wave. Then you would have the intervention, which is the town hall takes place, and subjects are randomly assigned in that survey, within that survey, to treatment or to control. The control would be a standard town hall. There's no peer control in this experiment. Then after the town hall directly, you have the first outcome measurement, and then you have another round of outcome measurement about 4 weeks afterwards. Those were some of the politicians who participated in this experiment, were kind enough to give their time to science. So now speaking about cluster random assignment, because this is the purpose of the session, what we did is basically we used pair random assignment at the town hall level, at the politician level, to determine whether during the town hall the representative would engage in democratic persuasion or not. This pair random assignment is a specific form of block random assignment. And so the assignment was blocked by legislator and clustered at the town hall level. And so everybody who was in the same town hall either got the treatment, democratic persuasion intervention, or didn't. And so there was nobody in the town hall who was was either assigned to treatment or to control. They were all assigned together to either treatment or to control. So it's a classical kind of form of cluster random assignment here. So that was the treatment condition. In the beginning, there was a short, brief introductory remark. Then there was a presentation that I gave on democracy during COVID-19 and some of the challenges associated with it. Then there was the legislator would respond to those remarks briefly, and then that was followed by around 45 minutes of open Q&A. It's also quite obvious that potential outcomes would be correlated in those town halls because people interact with each other. There is a pre-analysis plan, as there should be, in case you're interested to look at it. I'm just going to walk you through some of those results. This is the manipulation check, and it just shows you that subjects in the democratic persuasion town hall were more likely to perceive that the topic of the town hall was actually about liberal democracy. What you see here, these are the cluster level means. Yeah, so you'll have basically 8 cluster level means on the left-hand side, on the left-hand panel, and 8 cluster level means on the right-hand panel. And that's also a good way of displaying experimental data. And there's a great paper by Alex Kopok, which is called Visualize as you randomize, kind of following the mantra, basically analyze as you randomize. And what we do here is, we make it explicit that our assignment was conducted at the cluster level. Yeah, I could have displayed the individual level outcomes there, but what I'm doing instead is displaying the cluster level means, which makes it clear to kind of an observer that this was randomized at the cluster level. Yeah, there are effects on satisfaction with democracy. People are more satisfied with democracy. They are more supportive of pluralism, and they're less concerned about the democratic rights in the crisis. We don't find any effects on, for instance, democracy being the best form of government, like of all the other kind of bad options out there, kind of paraphrasing Churchill in a bad way, or on populism type of indicators. We also don't find any effects on behavioral measures. This is, I think, one example of where cluster random assignment has been used. It's very important that we cluster, like basically our standard errors here at the level of assignment, which is the town hall. Yeah, if we don't do that, this comes with a penalty in our case as well. A smaller penalty because people can select into the politician, people select into the politician, but we block on politician. So therefore, we can account for lots of for quite a bit of that variance there. But there is a small penalty attached to that. Yeah, so that means that we would underestimate standard errors if we wouldn't cluster at the level of assignment. I'll give you a second example where the penalty to clustering is even larger. And that's also the example that we'll use in a minute in the R demonstration, which is the effect of voter registration ads. So, or just like social media ads. So that, as I said, there's a lot of spending going on social media, obviously in the context of election campaigns. So one of the questions is, can we use social media ads to register some of those groups, young people, ethnic minority voters, voters with low education levels that might be harder to reach by traditional methods, and that might spend quite a bit of time also on social media. There have been a few studies looking specifically at vote shares and turnout. One of them also two of them in Germany, conducted by Anselm Hager, was at Humboldt. But like not much actually on voter registration. Also, there seems to be, I think, given the importance of the topic, there's a lot of spending going into this. Very few experiments have been published on the topic, which is either a sign that experiments are really hard to do on that topic, which is true, or also that there might be a lot of null results in file drawers somewhere, which I think is also true. So what we did is we partnered with a civil society organization called Vote for Your Future, who wanted to specifically motivate young people to go and register to vote. In the UK, you have to register, you aren't automatically registered to vote. These were the type of ads that were shown on Instagram and on Snapchat. And those were the two platforms that we targeted here. They were relatively, brief interventions, actors or influencers talking directly into the camera saying, if you care, register to vote before the deadline. Basically what we did is like assigning half of it was conducted at the postcode sector level, and half of those postcode sectors were assigned to treatment, the other half to control. So now there are two different levels of aggregation here, talking about cluster level assignment. There is the postcode sector, which is the level of assignment. There were about 900 postcode sectors. And then there are postcodes, nested within those postcode sectors. And the postcode level is we can obtain outcome data at that level. We can't obtain it at the individual level because we don't know if somebody is not registered to vote. But you only appear in our sample once you're registered. Hence, we need to aggregate over some type of spatial unit, which is in this case the smallest unit we can obtain this information at is the postcode sector. And so in this case, you would have how many individuals are registered in postcode. This was my postcode at the time, SE114BE. Yeah, then you would see that there are like 3 or 5 or 10 people registered. In this case, we can also aggregate it over the postcode sector, but we would lose statistical power. Yeah, we would throw away information if we did that. Again, there's a pre-analysis plan if you would like to look at it. Just like, very brief overview of results. In this case, I show you the, again, the cluster level means. Yeah, so this is basically the means at the postcode sector level. And what you see here is that there was no effect of this intervention, right? I mean, there was no effect of this intervention overall. And there was no effect of this intervention for people where we can actually know whether they are young or not. Yeah, so we can know the age for about 20% of our sample. We also do not find any effect at all of those social media ads on young people. And that was actually the most important youth voter registration online campaign that was run in the context of the 2019 UK general election. And we have, I think, quite clear evidence that it did not lead basically to an increase in youth voter registration, unfortunately. Yeah, so this were really kind of two examples here that I gave you where cluster random assignment was used. In both cases, really, because it had to be used, and there was no other way of really of handling this, since individual level assignment wasn't an option. Do you have questions before we get into the R part? Yeah, that's a good point by Linda, right? I mean, so you're asking how much confidence is there that people actually interact or engage with the ads online? So we have evidence on that. And, you know, it was a fairly popular campaign. I think it had about like, so I can't give you now on the top of my head the click-through rate, but I think it had like 2 million impressions overall. I think about 15 to 20,000 visits basically on the clicks on the ad, which isn't a terribly great conversion rate, I think, but it's, you know, there was definitely engagement going on with the campaign. It was actually considered by the organization relatively successful, you know, online campaign. Yeah, but engagement is an issue. Yeah, I think so. At the time, I didn't really, because I was also only kind of getting started with kind of looking at the effects of digital ads. I thought they were relatively kind of good numbers, which they are in the absolute kind of sense. But like if you break it down to how many individuals were actually included in this experiment, probably about like 1 million people. Then the proportion of people engaging is relatively low. Yeah. And then if you assume that you know, only a share of those that engage, you know, this engagement will actually lead to a change in behavior, then we are really in a world where it's difficult to power this study as well. Even at the level where you treat, you know, where I kind of have an experiment that has 900, you know, postcode sectors included in the experiment. Yeah, so I'll show you that in a second. So how does random assignment of clusters? Oh, you mean the first? I'm not 100% sure what you mean by that. So I think by random assignment of clusters, probably you mean, so what's the penalty of clustering, of assigning at the cluster level? I'll show you that in a second. It's quite severe. And so we would be much better powered if we were able to estimate, you know, the treatment effects at the basically without clustering at the postcode sector level, because we have like over 100,000 postcodes included in that, right? But it's a multiple of, you know, like of you know, of really 100 compared to, you know, postcode sectors. So yeah, standard errors increase significantly. Then you for the Zoom town halls, yeah. So how do we ensure that the treatment was the same? That's also a good point, right? I mean, in this case, so there was the presentation, which was always the same. And then basically we had a meeting before with the politicians, about like 20 minutes meeting, a half an hour meeting, where we explained the purpose of the treatment and where we really kind of walked through with them about what, you know, like that kind of strategy of democratic persuasion. Again, I'm very happy to send you the working paper if you like. which we developed. And so, you know, there was again kind of differential compliance with that kind of treatment amongst politicians as well. Some of them were more likely kind of to stick to, you know, like what the intention of the treatment was. Others were a bit less likely to do that. But overall, you see, for instance, we do automated text analysis, and you see that, you know, they were much more likely to talk about democracy in one condition than the other. Yeah, but it's what we call a composite treatment. So there are a lot of things going on there. Yeah, about how to explain the results, and then I think we need to unfortunately switch over to R. And I'm also going to take the last question there. So how to explain the results? I mean, like so they are quite puzzling. Obviously, we hoped that those effects would show results, and we replicated the experiment now in the local elections. 2022 in the UK, we are at the moment engaging in outcome data collection, which is also turning out to be a bit more tricky than we hoped. But we'll have, you know, basically replicated results on a larger sample, significantly larger sample, available for you soon. One hypothesis is obviously that noise, right? I mean, like, so these kind of ads, they get swapped out by all the other things that are happening in a general election campaign. You know, people are bombarded with kind of social media ads. So, you know, on it more or less, what difference does it make? It's one explanation. Another explanation is that the type of ad, the message wasn't right. Message was pretty much focused on cognitive engagement, so firing people up. Some people have said that, you know, people were already quite fired up. It's not about firing people up. It's about getting people who are fired up actually to register. It's more of a procedural type of task. So we have done some testing on this part there now in the local elections, if that might be an issue. It might really be power, statistical power. It might just be too noisy. There might be a reason for why there are so few studies on this type of question. It's just really difficult to power it adequately. That would be the kind of the less, you know, like encouraging option. So I'm waiting at the moment for the data from the 2020-21 experiments to see if we get another now. Yeah, and then just last one. How can we be sure that the control group was not targeted? Again, we can't be 100% sure. So, you know, we used Facebook's location targeting, which is based on the place, you know, where you live. Now, I've had conversations with people at Facebook, and there's a bit of a question of how good this targeting is. I mean, we're talking about the postcode sector, so that's a relatively large area. It's not your building or something. It's so they should. I thought they should be able to tell that, but there could be some spillovers going on here. Yeah, so it could be the case that some of the control group also received at least share or part of the treatment. But I would still hope that the dosage in the treatment group would be much higher than in the control group. Yeah, but it's nothing we can rule out entirely either. Okay, great. So thanks for the amazing questions, and I'll just walk you through the data actually of the social, you know, ads experiment, and you can see with your own eyes what happens to the standard error if we cluster. Do you now see my RStudio file? Do you see my RStudio now?
Yes,
yeah,
we see it. Thank you.
Perfect. Right. So you know, same little routine as last time. We should set our working directory, and then load the specific packages that we will use, which is the tidyverse, the estimator package, randomizer, and also going to do a little bit, use some functions of the randomization inference package here. The text rec package just gives you output in text format. If these are all included in the installation script in case you haven't installed them yet. Now, so what we do here is load in the data file. And this is basically a subset of the data which is de-identified at the postcode level. Yeah, so I don't include any postcodes here in in this file just to protect the anonymity of potentially of subjects. So here we have the postcode sectors, but those include usually about like 1,000 people. So there's no real big concern at that level. What you can see here is just the different variables that are included in the data frame. Yeah, so as I said, this was actually, I didn't say this yet, but this was block randomized at the constituency level. A register is our treatment indicator, takes on the value 1 if you received voter registration ads and 0 otherwise. PS is the cluster level, the postcode sector. N no miss is the main outcome variable, which is the absolute number of people registered in the postcode sector. And N young is the absolute number of young people registered in the postcode sector. Yeah, again, here we can look at the at the data frame just to see how our data actually looks like and how it is structured. You see that this was one specific postcode sector in this case Aberdeen South, which is a parliamentary constituency in the UK. In that specific constituency, in this specific postcode sector, in that specific postcode, these are all postcodes in the same postcode sector. You'd have 7 registered people, 1 registered person, 6 registered people, 13, and here only 3 young people. If in this case outcomes are missing, that means that no young person is identifiably registered in that postcode sector. In this case, what we do is we set this number to 0. Yeah, that is why this variable is called no miss. That's why it's called basically N young with miss. So with missing, basically imputation of 0. But it doesn't matter if we impute that or not. The results are basically the same. Right. So what I want to do analysis-wise is I first want to do the analysis wrong, and then I want to do it right. And then I want to compare the standard errors that I get if I don't cluster, and then afterwards if I cluster at the level of assignment, which I should. And so I call this first model standard errors estimated in a naive way. In this case, I always use the LM robust function, which is part of the estimator package. What that does is basically it applies a basically a heteroscedasticity correction. So it would account for the fact that in this case our outcome variable is not normally distributed. Some violations of the linear regression basically assumptions that are common in this case. You can also log transform the variable. It doesn't change basically the results here. Yeah. But what I do is I don't cluster the standard errors, right, at any kind of level. So in this case, standard errors are estimated at the postcode level, not the postcode sector level. And then I extract the information that I want from that function. Then afterwards I'll display the output. Yeah, now what I'm going to do is I'm going to do the same, run exactly the same regression, but at this time I cluster my standard errors at the level of assignment, the postcode sector. Yeah, so in this case, again, like obviously coefficients shouldn't change, like a beta coefficient should be exactly the same. What should change is the standard error, and the direction in which it should change is that it should be larger if I cluster the standard error at the appropriate level. Yeah, the little kind of red sign here means that it's working. It will take a bit more time to take account of the clustering. And I output my results here. Yeah, and the results are basically very, likely. I mean, I've already previewed them to you anyways. So, there's no effect of the voter registration ads on voter registrations. these are not percentage points here, right? I mean, these are just basically absolute registrations. Yeah. What you see here is that the standard error, estimated, this is not significant, obviously, by any kind of, by any measure. But it's, estimated to be much smaller if you use the postcode level than if you use the postcode sector level. Yeah, so here the standard error is like almost, 2 to 3 times larger if we cluster at the level of assignment. And this is the model at which we cluster. Obviously, the estimate is unchanged. Yeah. Now but this is for everybody. Yeah, this is for all registration. Obviously, the ads were only targeted to young people. So what could have happened, obviously, is that maybe we find effects for young people, but not for older people. And that's actually the exercise now that I would like you to perform in breakout rooms. So in this case, please run the same regression once, not clustering your standard errors and once clustering your standard errors at the level of assignment, using the second outcome variable, which is called nyoung underscore with missingness. So basically where we impute zeros for those postcode sectors that don't have any kind of registered young people there. Then compare your results and report back to me, please. So if we can now break into breakout rooms for about 7 minutes maybe, and then return to class, that would be great. Thank you. Okay, great. Let's go back. What's the result? What did you get? What do you think? So if you compare first, the effect of the registration ads for young people, model 1 and model 2. What would your interpretation be? Anyone has a take on it? Yeah, clearly something happens again to the standard errors there. Yeah, so maybe if, Sharon, do you want to come in?
Yeah, I can. We can see that the independent variables size increased and it changed direction, but intuitively, I'm not really sure how to interpret this when we changed outcome variable.
So this is the coefficient. Yeah, you're talking about the coefficient.
Yes.
The coefficient changed sign. That is correct.
Yes.
Yeah.
And the size seems like the magnitude of the coefficient is bigger than the previous model that we.
It's also statistically. Yeah, exactly. You're right. Yeah, it's also statistically significant. It's negative. Yes.
Yeah.
So if we were going with this specification, then we would conclude probably falsely that the digital ads had a significant negative effect on young people's voter registrations. Once we adjust for clustering, basically we cannot reject the null hypothesis that the true effect of those ads was 0. Yeah, but again, it really matters. Clustering of standard errors matters because in this case they're like almost they're twice as large, right? I mean, if we cluster at the correct level than if we don't. Meaning, if you don't cluster at the correct level, you might draw the wrong conclusions from this study. Yeah, so that's just important to know. Yeah, I mean, so clustering can have quite severe penalties in terms of precision associated with it. It would have more in this case than in the other case. Yeah, because cluster level, basically the variance between clusters would be higher here than it is in the town hall case that I gave you before. Yeah. So now I just want to. I think we're gonna run over for about 5 to 10 minutes. I hope you can bear with me for that. I just wanted to show you how to perform cluster random assignment, again using the randomizer package that Katerina has already introduced in the previous session. So in this case, what we want to do is we want to assign postcodes by postcode sector to treatment or to control. So the first thing that I actually would want to do is I'd like to know, how many postcode sectors there actually are in my sample. Yeah, or I would like to look at my data in a bit more in a bit more structured way. And what I see here is basically, of course, there are also 717 rows, meaning there are 717 postcode sectors in my data. And you'll see, that these are the n, in this case, the postcodes, in each postcode sector. Yeah, so there are some postcode sectors that have only 2 postcodes in them. There are others that have 233 in them. So that is actually one case where, the number of clusters is quite unequal. So we're just lucky in this case that the sample is relatively large. Yeah, so bias is going to be relatively small. In this case, in the estimator, just because our sample is like in the hundreds. Yeah, if that would be kind of, if we would have randomly assigned 25 postcode sectors to treatment and 25 to control, we'd probably have to switch the estimator to the difference in proportions from the difference in means here. And again, that would come with significant, penalties in terms of precision. And what I want to do now is, in this case, I want to show you the assignment, as of what the assignment actually looks like. And what I do here is I conduct a design declaration using the the RI2, like the randomization inference package. What I do is basically I say, in this case, I had assigned 717 subjects, like that were part of my sample. And I had assigned approximately half of them to treatment. M always stands for the number of subjects assigned to treatment. I had clustered my assignment at the postcode sector level, which is basically what I indicate here. Then you can look at this assignment, and it basically tells you what type of assignment you're dealing with. In this case, you're dealing with cluster random assignment. You have 90,000 units here in your postcodes in your sample. It's a huge sample, right? I mean, I would say that counts as big data probably. You have 717 clusters because I said 900 in the original experiment. That excludes Scotland because we had some issues matching basically registration files in Scotland. So we're still waiting for that data to come in. 2 treatment arms, and probability of assignment is about 0.5 here. So what I want to do now is I would like to reassign my postcode sectors, or the postcodes by postcode sector together, like in postcode sectors, 2 or 3 conditions. Yeah, in this case, maybe I don't want to just like test the effect of like a social media ad versus the control. I might want to test different messages. In this case, what we wanted to do, for instance, in the follow-up experiments that we conducted in 2021, was we wanted to test cognitive messages, which were the kind of fired up messages that the campaign used in 2019, and then non-cognitive messages that were more kind of really geared towards follow through, for getting people who were already fired up to actually complete their registration. And in this case, what I want to do is I want to assign subjects with a probability of 0.33 to each of those conditions. Yeah, so this is basically my 3-group experiment here. I have also, what I'm doing here is I just replicate the random assignment. Yeah. So the code here is relatively straightforward. The function is basically saying cluster RA instead of complete RA, if you remember the other function. And then I just need to indicate the cluster variable. Yeah, I need to tell the function which, the variable is at which I would cluster. And I need to indicate the number of clusters in the sample. Sorry, I need to indicate the number of clusters that I want to assign to treatment, which is 359. Same here, only that I use the function meach, which indicates, like the number of subjects, postcode sectors per condition that I want to assign, which is 239. I can do that again using the mutate function, which is basically I'm creating a new variable here using the tidyverse grammar. In this case, I just rename one of my variables x as postcode. I create a new variable called cluster_z. C always stands for treatment assignment, which is the result of my complete random assignment at the cluster level, where I assign half of the units to treatment. I create a variable called cluster3group, which is the result of my cluster random assignment function into 3 groups instead of 2 groups. And then I add those newly created variables to my data frame postcode that I created here. Yeah, so I first take the data frame, I pipe it into the mutate function, and then I create my 3 new variables and then add those 3 new variables to the existing data frame. Again, I set my random number seed before. Yeah, after I've done that, for instance, I can check the data frame if you like to see if this worked out. Yeah, and you see here, can you see that actually now? Yeah, you can see the newly created random assignment, indicators here. Your binary assignment indicator and then the 3 group indicator. What I can do now is I can just display the random assignment. And what I would like to do is, like, first of all, I want to show you that it kind of works, right? So in this case, I show you the number of, in this case, postcodes assigned to treatment and to control, and also the frequencies. Sorry, the frequencies, the portions here. So you see that, what the random assignment function in randomizer did is that it cluster randomly assigned about 50% of the postcodes to treatment and 50% of the postcodes to control. We can check the same for our 3 group assignment. Sorry, 1 second. For 3 group assignment. Again, here, probability of 0.33 approximately to the 3 different treatment conditions. This will differ slightly because what we randomly assign is we randomly assign postcodes by postcode sector. And there might be, as you know, there might be different number of postcodes by postcode sector. So in expectation, it should be 0.33, but the probabilities can differ a little bit here at the postcode level. Now I also just wanted to show you that the assignment actually worked by cluster, and that you can see here. But in this case, you see that each postcode in postcode sector AB101 was assigned to the same condition. Right? They were all assigned to T3 in this case. What you would expect with complete random assignment would be like T3, T2, T1, T3, T2, and so on. Yeah. Same here. Yeah, you see that same postcode sector is assigned to the same treatment condition. So this is exactly what we want to see. Great. So final exercise for today. So I'd like you to do the same, but actually assign those postcodes into 4 experimental conditions: 1 control and 3 treatment conditions. If you could also name them as before, like in Katarina's exercise, that would be great. As a little kind of complication, I would actually like you to assign 40% of all postcode sectors to control and 60%, 20% each to the 3 remaining treatment conditions. Yeah, so if we can go back one last time to our breakout rooms, that would be great, and then reconvene in 6 to 7 minutes for a final discussion. Great. So so we are back. How did it go? I guess they're waiting for some people.
Yeah, sorry, I didn't press close the rooms on time, so it's going to be in about 40 seconds. Sorry about that.
Sorry for overrunning a little bit. Jen, do you want to share your screen?
Yes, of course. Okay. I hope you can see it. This is what we
just wait for 1 second, because not everybody is back in. I think
okay.
we're just waiting for people to come back.
The rooms are closed, so I think people should be back.
Okay, perfect. Thank you. Sharon, do you want to walk us through the code briefly?
Sure. So we followed Florian's code from the session. We created 4 groups instead of 3 right now, 1 for the control group and 3 for each 3 treatment groups. We calculated with a calculator what 40% of the 717 would be for our control group. That made 287. Then we had 20%, 20%, and 20% for each treatment groups. Then we named, following what Katerina showed us in the previous lab session, using conditions command. We named each treatment and control groups. And then we managed to assign our data to each of the following randomly assign the following 4 groups.
Great, perfect. Do you want to execute it and see if it works?
Yeah.
I think there's just a very little mistake actually in the summarized function. It should be cluster for group instead of cluster X.
Okay.
Yeah, that looks good.
Yeah.
That looks good to me. Yeah, so in this case, we have assigned our different postcodes by postcode sector to 1 control group and 3 treatments groups with differing probabilities. Right? I mean, 40% to control and 20% each to one of the treatment groups. Yeah, so this is just to show you, first of all, thanks a lot for demonstrating this, Sharon, much appreciated. And it's just to show you that, you know, random assignment can be really easily done using the randomizer, you know, like package. Even more complex forms of random assignment, including cluster random assignment, block random assignment, which we haven't done here yet. There is extensive documentation online for all of those packages, as it's, you know, common with R. And I would encourage you to, you know, use Google freely if you have any, you know, like questions on that. Also, like just to know now, I didn't really get the opportunity to really get to know you personally, but I think I also speak for Katerina if I say that, you know, we'd be really happy to talk to you if you have ideas for experiments that, you know, that you would want to run. Very happy to advise on experimental design. You know, read your pre-analysis plan, look at your random, you know, discuss different design choices with you or random assignments if you would like. So this is very much, I think, sort of as a start to a conversation. You know, like I think the experimental community, is quite welcoming, and I would certainly be, and very much looking forward to, to hear, any type of ideas that you might have and that you would want to conduct, and very happy to support you in executing those. So with that, I would like to thank you all for, first of all, coming along and attending this workshop, bearing with me for overrunning a little bit. I'd like to thank Katarina for the great work as a TA on this module, and Olga and Hugh for organizing, and of course the Hertie School for putting on this amazing, really, summer school, which I think is a really great initiative. So yeah, looking forward to hopefully keeping in touch with many of you, and seeing you at the other ODD conference, hopefully in person sometime soon.
Thank you so much, Florian and Katerina. Lots of gratitude on YouTube and here in the chat. And yeah, thanks a lot.
Thanks so much. Have a great afternoon, everybody, wherever you are.